actually look like. Yesterday, I focused on the important point here specifically. I hope you're able to see the zoomed screen, right? We discussed about this aspect, right? When we talk about, right? When we start, right? These initial starting phase, right? As to what happens in a transformers, even without like going into the in depth. So today we'll look into few more things, right? A little bit more talk about it. In fact, I'm wrong to denote this entire thing because as of now, I haven't even told you about this particular segment. You all see this particular, what do you say, yin yang kind of a symbol or a what do you say? Dragon ball, Pokemon ball symbol or whatever you call it, right? So, in the context, right, which gets attached to, right, we're going to talk about and look into that aspect. Okay, so, but the whole idea is input embeddings we have discussed, right, as to what happens, right, in the context, right. I told you about a higher dimensional space, right? So, and yesterday, I think more or less, I hope everyone got the understanding, right? Like since a few of us have joined up here, right? I'll just quickly zap through a few things, okay? Interesting stuff which we saw in yesterday's class was how a word can be represented in its corresponding meaning in a lower dimension, right? So I hope that was clear, but let me just quickly come back to it, right? Let me run it. I'm not going to elaborate it further much because we have seen it, but I think, Adarsh, you have joined today, right? So Adarsh, I think you're not there yesterday. So I'm just quickly zapping through, right? Let me run this and run all cells. I'll just go ahead and do that. Uh, as we had discussed about, nothing much. I'll not much talk about it, but however, just to give a quick overview about it, right? How things look, right? So in the space here, right? We discussed about that, right? What I'm trying to do here, there are few words which are going to be represented in these terms, right? These are X, Y, Z coordinates, whatever you call it, right? However you think about it, because we saw that machine understands numbers rather than it does not talk about in the context of what happens in words, right? So I have few numbers, random numbers, but these are not so random. Okay. I did not say it yesterday, I believe. These numbers are not random. They have been fixed, intentionally put in that manner so that where when you talk about male version of the something, right, man will be on the same side of the things, right, king will be also on the same side of the things, right. What we are trying to measure is basically three different analogies if I talk about, right, in the context here as the plots, right. We talked about the gender, the royalty status, and whether something can fly or not, right, if I talk about, right. And I told you in the context of planes, right, how it looks like and stuff, right. We were trying to prove the point that something minus something plus something gives the fourth output, right? The vector, like that's how a vector is visualized in the context of the space here, right? Same way we have the, what do you say, 2D projection here, right? So, as I told you, our intention is not to understand much on the code, but what is happening. Okay. So here you can see for the gender on the Y direction, on the royalty on the X direction, you have few things who go in the, obviously, these are all in the context of the female characteristics, right? Lioness, queen, women. I think now you can understand. It is safe to understand that whatever vectors I created, right? Those, I should say, yeah, it is actually a vector, a single line vector, which I created there, right? That was intentionally created so that it separates genders, right? Similarly, you can see here that in the context of, right, you have rooster and drone bee and stuff, right? Where you can see can fly, obviously one, that means yes, they can fly. And supposedly -1 means they can't fly. Here I'm taking three different numbers, right? Although I could have simplified it using 0 and 1, right? Where 0 denotes something else, right? If I talk about, but I wanted to give a realistic feel of how the things work out, because you'll see the numbers generally oscillating between -1 to 1. Okay. So that's the whole reason why I have put it in the context here, right? Same way you can see the royalty versus, can fly, right? If we talk about. So same way we discussed about it, the 2D projection, and you can see the things, right? Now, moving forward, yesterday we also discussed about the globe, right? So if I go to that quickly, and I think more or less we all understood the context here. Like I use the same package which was used out by dear Sir Jay Sir as well, right? So, however, this is the projection in 3D. That's the talk about the stuff, right? Here you have 50 dimensions, right? I told you, right? This 50 matters because it gives a number or it gives a vector which is existing in 50 dimensions, right? So if you count these numbers, we saw that len of that number turns out to be 50, and it has been trained on, I told you the vocabulary size as well, right? 400,000 or 4 lakh words it has been trained on, right? That's a global vector for word embeddings, or globe in short, right? Which was earlier also discussed by our dear Sir Jesser as well, right? In his session, right? So, and the idea is, right, you have so many, I told you, right, you have so many numbers of, what do you say, so many numbers of dimensions, right? So the whole idea is somehow you imagine that you want to reduce these many number of dimensions to fit into three dimensions perspective. And for that, one of the mechanism, which is very popularly used, is probably if I talk about the PCA, right, or principal component analysis, right, where you project those onto a lower dimension, right, if I talk about, and that is what is happening here. So you see, I told you there, right, you see this tower word, right, if I talk about, right, you come across in the context here, right, the tower word which exists in the three-dimensional space with these set of values, right, x being some value, y being some value, you can see, and z being some value, right? If I talk about, right? So that's the whole point, right? However, if I talk about in the context, look at this here, right? So if you look into the stuff, right? I added some more values, right? Out of those 400,000 or 4 lakh words, these are the few words which we have taken here, right? So uncle, aunt, or something in those lines, right? The reason to take it, as I discussed it yesterday, you can see very close proximity of similar words, right? Boy close to girl in the context space as well, right? Woman close to man here, right? And if I talk about in the context, this is what I wanted to discuss about. But I told you, as you are losing dimension, I told you a very important point yesterday, that as you are losing dimension, you also tend to lose some important information there as well, right? And that is why some, and also that's not just the point. One point is that, the other point is, there is a possibility that a word is being used in different context, right? So for example, I say that I'm sitting on the bank of the river, right? That word bank, right, is the bank of river bank, right, if I talk about, right? Whereas if I compare it with the word like I'm going to the bank, right? So the words, two words having the same meaning, right? Sorry, same words, right, but contextually different because they are being used in different stuff, and that is the reason why it gets shifted. You see these stuff a little bit getting shifted on the context there, right? And then yesterday, we did something more interesting as well, right? We saw that what is the actual projection of the girl? And what is the predicted one, right? If I talk about, right? So you see here, what you see here is the girl, which the point of the girl, which points actually in the word space, right? Which is yesterday we saw that those values, right? Whereas if you do something like the analogy which I've written here, right? Just like we say boy minus man plus woman also is equivalent to girl, right? That comes out to be this red point here. This is also the girl point, right? But you can see that they are very much proximally, very much close to each other, right? Like how we discussed yesterday, right? So that is the motivation behind what we are talking about here, right? In all of these contexts, right? Moving forward, we also discussed about many word scenario, right? Here you can see a lot of, and some of, thankfully to you all, right? You also gave me a lot of words, vocabularies here, right? So we try to project them here, right? And just like that, what we wanted to prove here is you can see these things, right? You have 2, 3, 4, the numbers. There were numbers like 2, 3, 4. You can see the projection direction is almost the same if I talk about, right? So that's what I wanted to talk about in the context here, right? So you can see brick, sand, relatively close to each other, right? So a snack and snacks, right? If I talk about, right, I mean, the plural forms relatively close to each other. If I talk about, right, you can see the number one is far apart, right? Can you see this number one here, right? But 2, 3, 4 are in the same direction because one can be used in different perspectives, right? So I say like one as a number, or maybe give me this one, right? Or when I say like that, maybe we are saying that this object, I'm referring to this object, right? So the context of the word change, I mean, the meaning of the word changes. So it gets or shifts to a different, takes some and shifts to a different perspective, right? If I talk about, right? So I hope these things are pretty clear to understand and stuff, right? Anyone having any doubts here up until now? Everything clear about it, right? Yes, all of us, please, some
Yes,
Clear,
Saumya.
clear.
perfect,
Yes,
perfect.
Soumya
Aman,
sir.
Yeah, yes, sir, yes, sir, yes, sir. Aman, sir.
Uh, just two things here I just wanted to
Right, sir.
ask.
Yeah,
So,
yes,
like,
sir.
whatever, like here we are giving the sentences. So, all the
Mhm.
sentences should be broken down into words and that will be projected, right?
Sir, actually, I'm not giving a sentence here. I'm
Like in
just
kind of a
providing
web
random
process,
words.
right?
They are words. They are
Okay.
words. They are individually words. Let me
Mm,
go back to the code
Accepting
and
the
show it to
random
you.
words, no, only.
Yeah,
And
exactly, sir.
giving the
Like,
yeah, just
okay,
embeddings
okay.
and just
huh,
embeddings
as
are
per the
only
So,
living
visualized here,
right,
just to show.
exactly. You
mhm.
can see here. Exactly, sir.
So based
Exactly.
on that words, these sentences will be like embeddings will be happening. Whatever we are providing from our side, that would be done based on those words, right?
Right, sir. Exactly. I mean, when I talk
So,
about, right, these words are responsible
mhm.
for those things. Huh, sir. You're saying something. Yeah, please.
Okay, okay. So, like, which model it would be using for finding? Like, if suppose the sand is projected in some particular coordinate, so how it
Right,
will
sir.
find that the
So,
sand, this is the sand, there it is
hmm.
projected.
Okay, sir, actually, that is what I wanted to clarify. That you see, how is it finding the question which you are asking, sir, right? That is finding. Let me go
Yes,
on
yes.
top. Yeah.
Actually, in
Sir,
DSA, we might have studied that
yeah.
we do some tree and graph
Huh,
algorithms and all, right?
huh.
So we
Exactly,
find out
exactly,
the
sir.
particular child of the tree.
Right,
But
right.
here,
Sir,
yeah,
yeah,
that's what I was.
yeah. Actually, sir, it's not about, to be frank, it has less to do with DSA. Here's the thing, sir. What happens is, can you see this? The model which I've loaded here, it's called as GLOVE, which stands for Global Vector for Word Embedding. Okay. Wiki, meaning it has used Wikipedia as one of the sources. Okay. GigaWord is also one of the sources. Okay. And 50 means you are trying. So whatever data you have collected is from Wikipedia. Whatever data they have used is from Wikipedia and GigaWord. GigaWord is also one of the repositories from where you can. So you might have seen, right? Any new word which we come across, right? These words would we try to find. We do wiki search, right? So if I'm new to it, right, I would rather use wiki search to understand what that word talks about, right? Aman sir, won't you agree with that, right? Wikipedia, we go to
Right,
Wikipedia
right,
and
right.
search. Yeah, right. So
Right.
imagine this. Yeah, exactly. Now imagine you go to wikipedia.com. Somehow there is a download button, okay, and you downloaded the entire Wikipedia, okay. Imagine, I'm trying you I'm trying for you to imagine here, right? So you go to all the pages. Imagine that you have, so basically how it actually happens in technical terms, we use something called as a web crawler. Okay, this is called as web crawler, meaning it goes to different websites, crawls on it, right, and fetches, takes a snapshot of it or keeps it and stuff, right, and then uses it, right? If I talk about, right, our idea is, imagine that there is a big folder called Wikipedia. Now, web crawler has gone to all the individual sites of Wikipedia and downloaded it offline, okay? And it has kept it, right? Okay. Are you with me there, Aman sir? Are you
Yes,
there?
sir. Yes, sir.
Yeah, got it. So similarly, you have another folder called GigaWord, right? Containing all sorts of things which you get from there, right? Or whatever, right? And now what you do is take these two big chunks of bags containing lot of sentences, in fact, paragraphs, in fact, stories, and what you do is, if I talk about, you're providing them as input, and then you ask the machine, right? These are, these happen unsupervised. Meaning, when I say unsupervised, you do not supervise what to get out of it. Okay. So what you ask the model that I need 50 dimensions, meaning I want a representation in 50 different perspectives. Do that yourself, okay, and whatever patterns you come up with, right, store it. You do refinement, you do a lot of set of refinement, and then you come up with the context there. These numbers are not randomized numbers. These have been, because you are training on a very big data set, right? It understands that when I write the word, I mean, when I say that, okay, I'm going to the river bank, right? This is a correct sentence, right? Because obviously, when you talk about wiki sources or giga word sources, whatever you talk about, right, they are grammatically accurate as well, because they are being written by human beings, right? Agreed, Aman sir, right? They are grammatically correct
Yes.
if I talk about, right? So when we talk about in that context, right? So it understands, so it does projections in, you see, it does projections in 50 different dimensions, and whatever set of values it comes across being very stable, right? You do it on a repeated set, okay? So if I talk about, right, you do it towards repetition, and then at the end of the day, it finally stabilizes with some view of some of the few values. Okay, so so the idea is, you take the giant corpus which may be containing billions of and billions of words, right? Out of that, you first find unique set of words, right? They found that the vocabulary size or the unique set of words was 400,000 or 4 lakh words, right? Now, for each of those 4 lakh words, right, you try to represent 50 different dimensions to talk about it. Okay, the one which was taken by Jay sir was bigger, meaning it was making the word to be visual, I mean, to be understood in 300 dimensions. Obviously, the more the number of dimensions you add more perspective. Do you get it? Is it understandable? So you can
Yeah.
simply think of dimension as a new perspective, right? Meaning a different angle to think about it, right? So that same thing can be thought of in different angles, right? If I have the context there, right? So but for that, you need flexibility to think in those many number of dimensions, right? Being humans, we are restricted with, I mean, using the spatial axis of our brain, right, which exists in 3 dimensions. But obviously, the gray matter inside of us, right, the head or the brain, does not just exist in 3 dimensions. It might be, actually exists in a higher dimension, right, but may not be as higher that of the GPT model itself. And that is why, in order to, what you say, compare it with the intelligence level, right, GPT gets the way out of it. But you should understand one thing, that it is not doing anything magical. It's all based on statistics, and it is just doing prediction based on something else, right? Did it clarify it, Aman sir? A little bit maybe. Are you able to
Yes.
visualize that?
Yes.
Right. So you
Yeah. Yeah. I
provide a
can
big
visualize it.
sentence. Right. Exactly. So when you provide a big sentence, it first breaks it into words, understands in his giant brain, where it has trained with so many number of numbers, right? It understands, okay, the word was can be now represented in 50 dimensions, right? Which dimension should fit to the other words, so that it gives a better representation of what am I talking about. Easy to understand, sir? Is it clear?
Thank you, sir.
Uh,
It's
no
makes
worries.
sense.
Okay, yeah, perfect, sir. Thank you so much So that was the overall idea, right, to talk about, right? Now, and on the perspective here, we were just representing words, okay? After coming up with so many different, like the actually the model did a lot of job about it. Like getting those 50 numbers is quite challenging, right? You put through a lot of what do you say? Like basically you gave it under no supervision at all, and then you throw out numbers, and based on that you end up having the 50 most suitable numbers which can represent a word, because this word was can be out of those 1 billion words, right? It could have been used in maybe 10,000 different sentences with 10,000 different meanings, right? So the way it came up with the representation is what is the overall idea which we are talking about. And to be frank, we are still trying to take that 50 and then making it compressed to 3 dimensions. Okay, so I think you can understand lot of information is lost during this entire process, but it still is okay because you are able to make nearby structures, right? Easy enough to understand for everyone. All right, so shall we move forward with the stuff? Is it okay to all of us now? Shall we move? Perfect, sir. Now, let me close this all off. I don't need this. Okay, let me go back here. Where is it? Yeah. So, I think more or less the story which we began with Ravan's, and I think to add up with Ravan's analogy, right? He had multiple heads. We still have not come to multi-head. Why I'm talking about that, right? Still, we are in the beginning phase, right? Okay. Let's move forward with the talk. Okay. So I think you can understand. Let me just give you an overall intuition behind. Okay, you have this, right? Or I should maybe use the presentation view. So you all can see here, right? Here, what I'm trying to do, right? Is basically establish something like a equal to sign between this, okay, and this, okay. So if I talk about, right, we are going to talk about what is attention head. Do not worry about that word for now, okay. We'll talk about it, but the whole idea is the different heads of Ravan signifies different things, right? Wisdom, knowledge, what do you say, vision, maybe strategy, maybe what do you say, foresightedness, or whatever you can think of, right? Well ahead and plan it ahead, right? If I talk about, right? Similarly, same way you talk about different perspectives, okay? These are like maybe you are attending to something like a syntax. When I say attending to, we'll talk about that. Okay, you're attending to semantics. Maybe you're attending to what you say structure or the text organization, right? Or the context of the word, right? If I talk about, right, situation on which it depends on, right? I think more or less a little bit of the fragment is clear to you, right? The word bank being used in different contexts, right? So that's what we are referring to here, right? So having different attention mechanisms to talk about in the context, right? So they can, if I talk about, right, you can see like Ravan's 10 heads processing information from multiple different perspectives, right? You have attention mechanism which allows the machines, right, to understand different context and capture different kinds of meaning in in a language, right? So I hope that's particularly understandable in the context there, right? So let me tell you one interesting fact. How many of us? What is so different about Sanskrit and English? Can anybody tell me the word the language Sanskrit versus English as a language? Can anybody tell me that?
So come again, please.
Sir, I'm asking what is the difference between what do you say Sanskrit as a language versus English as a language? What do you think?
So,
What are your thoughts?
like our speaking, obviously, how we pronounce the meanings of the words, and
Uh-huh.
as well as definitely how we structure the sentences. That's the most basic and the most important thing.
Awesomely said, sir. Exactly, that's correct. Awesome. Nice.
First of all,
And yeah, you
me
said.
and Uma Bharati Raja actually don't have much idea about Sanskrit language
I
because
understand, sir. Okay,
It's
so
not
let's say
that
Telugu.
much existent in
Sir.
South. Yeah,
Telugu.
that we can take example.
Huh.
Yeah, that is
So
what
if
like
I talk
us
about
and
Telugu.
the way of pronouncing the word in English and in Tamil or Telugu, that will
Right,
differ. Okay, even though even English also in our side we used to call it as a Tamil plus English, that is called Tanglish. So we used to
Okay.
pronounce the way we used to pronounce Tamil, the similar way we used to pronounce the English also. And if you are
English
talking
also.
about like Malayalam, Kerala, most of the
Right,
places,
sir.
like we used to say office, like in Kerala, they used to say office. Okay. In similar
Okay.
way, hospital, like we used to say hospital, like in
Right.
Malayalam, like Kerala, they used to say like hospital. Like that.
Right.
The whole sound is
Sir,
remain like
what do
the
you
based
say
on, yeah,
for
man.
BG?
Sorry, sir.
For BG, what do you say, sir? I think BC, you say something like no BG,
That
BG schedule.
paying
So
paying
what will you
guest,
say?
that is or what?
Busy schedule.
No, no,
Sir, I think sir
BG
is
schedule.
asking
What
what
will
do
you
you
say
call
for
in,
that?
yeah, this busy schedule or something in those lines
Busy schedule,
in
busy
Tamil.
schedule same.
Uh,
That is same. Actually, kadinamana velai, like in Tamil. That maybe you may not understand, but
Sir,
that is.
the reason
But
why I asked this question to all, right?
Mm.
Okay, let's consider the language English. Let's
Uh,
consider the
it
word
is it is the
Tamil.
sentence order which comes, I guess. In Sanskrit and
Right, sir.
English, there is a difference in the order. Like, for
Right,
example,
exactly.
if I say in English, if I want to say that I am a trainer or I am a student,
Mm-hmm.
it has this fixed order, right? So, like
Right.
in English, but in Sanskrit, I guess it is like it's not I am a student. It will be
aham,
like aham
aham trainer.
chhatra, aham trainer,
Chhatra.
aham
Yeah, it's
trainer
a
asmi something.
Asti, sir.
Asti,
Trainer,
asti.
Asmi. So it will come like I student am.
Asti. Right, exactly. You're right, sir. I
I
mean,
think
the
others.
idea is,
Yeah,
yeah,
continue second.
But
I was just
एक
commenting.
और
Actually, others, I
word
guess
है
he knows Sanskrit. I guess.
No,
little
I
bit.
don't. I had an interest to learn once upon a time, but I didn't continue. It was a little tough. Sanskrit
संस्कृत
is
हम लोग को भी पढ़ना था ना छोटे क्लासेस में तो बालका बालको बालका बालकम बालको बालका
Yeah,
करके ऐसे
sir.
लोग पढ़ते थे
Actually,
ना
I wanted to come to this
हाँ,
point. You are right, sir. Balaka, balako,
okay,
balaka. Yeah, exactly, sir.
बालकम
Sir, the reason why this comes up, you're very nice. You have nicely said it, sir. If you understand the vocabulary in Sanskrit versus the number of vocabulary means the number of words or alphabets in Sanskrit versus or maybe the number of alphabets in Tamil versus the alphabets in English, if I talk about, right, you will see a huge difference, right? Huge difference. Like, for example, you see, like, for example, 26 alphabets, right, from which all the words are made, right? That means you have a little bit of, I mean, there is a constraint in the number of words you can form, right? There is a constraint, right? And that is why there is an ambiguity, right? I'm using the word ambiguity in meaning one word can mean different things in different contexts, like the word bank, which we just discussed earlier, right? If I talk about, right? So इस वजह से, if I talk about, due to this, right, you get that confusion, right? The words get confused, right? But the reason why I brought in Sanskrit in all of this discussion is because, or maybe Tamil as a matter of fact, if I talk about, right? So it is because of the fact that the vocab size of these languages are bigger compared to English, right? So if I talk about, understand this, if you give me, suppose I wanted to create a transformer. For now we don't know that transform, like consider transformer as a black box, right? So suppose I were to given the task of creating a transformer, right? You don't have to put in a lot of effort, like you don't need a lot of different dimensions, okay, in order to represent the words, especially in, if I talk about in the context of Sanskrit, maybe, or maybe Tamil, because the fact is each single word represents a single single meaning, right? You don't have multiple words meaning or that kind of a confusion, okay, to talk about, right? So I think you can understand the architecture of what you say, the transformers, right? If I talk about, more or less also depends on the vocabulary which we are considering. That is why you have to put different angles, right? You have to put effort in putting angles, right? Okay. You have used the word bank. Okay, am I referring to river bank? So that is angle one or dimension one. Am I referring to what you say, bank where you get notes, right? If I talk about that is angle two, right? And when I say note itself, it is ambiguous, right? Note means, are you talking about Gandhiji notes, or are you talking about you are taking notes, right? So while I'm taking the lecture, right? So you understand that that's the because of this ambiguity, right? You wind up having more number of focuses to find different perspectives to understand. Okay, you are referring to this, and that's why. Okay, so in general, if I were to design a if you ask me, Saumya Chaudhary, to design a transformer for maybe let's say Sanskrit based text, right? I might not use 12,000 dimensions like yesterday we discussed about, right? I might use, if I talk about, I might like reduce the number of dimensions, because I know that in Sanskrit, each word has a separate meaning. And that's why you have that 7 into, right? Just like how Aman sir said, right? Gach has so many number of variants, right? Balak has so many number of variants, right? You have 24 variants to talk about, right? And where to use what is exactly decided, right? So you don't need a lot of effort in design. Are we able to understand how what would have been the thought process behind the ones who created the transformers? Is it understandable by everyone? A little bit, maybe.
Yeah, yeah.
I mean, it's a vague understanding, but I just want to keep this perspective in check so that we all understand. Perfect. Awesome. So let's move forward and discuss about few more things. Okay. So now, if I talk about the foundation, right, word embeddings, which we just talked about, right? Yesterday, I think more or less we discussed about it. Now I don't need to blabber a lot about it. So the one which you saw me using was glove, right? In the code which you saw me using was glove. There are others as well, like word to vec and BERT as well, right? Do you remember what is the full form of BERT? I said it yesterday. BERT. What is the full form of BERT? Remember? Anyone?
Bilingual something, right? I use
By
No.
fine.
It is B for bidirectional. Okay. B stands for bidirectional. Okay. E for encoder. Okay. Bidirectional encoder. R stands for representation. Okay. And the final T stands for transformers. But bidirectional encoder representation from transformers, or using, you can also call it using transformers. I think you can understand, right? The encoder is basically, if I talk about in the context of, right, you are trying to create a word embedding. Okay, you saw me using word embeddings in 50 dimensions, right? Using the glow, using glove here, right? So BERT is also similar, right? If I talk about, right, but in a higher dimensional space. But since this guy has been created using transformers, you see the word transformers, right? It also takes in account of those ambiguities as well. The glove does not take in that account. Okay, is it understandable to everyone? Is it a little bit clear, right?
Yes.
And what is the output you are getting? The output which you are getting is some n dimensional representation, which you saw like vector representation. Okay, but the whole idea is you are getting this through as an output of transformers. You're using transformers to get it. Okay, so you will understand why you are, I mean, what is so special about transformers? We could have done the others as well, okay? And for that, we are going to learn about, right, the things which is happening inside a transformer. But as of for now, you should understand that BERT is a representation of the same word, okay, existing in BERT n dimensions, whatever the n dimensions BERT has. Clear about, easily able to understand? Everyone got it? This particular perspective.
Right.
The output is from Yeah, exactly. So from the stuff here. Okay. So I think you can understand. And there is a word called bidirectional, if you talk about, right? Bidirectional meaning you are basically guessing the word. You remember, right? If I talk about, right, you're guessing the word from two different contexts as well, right? If I talk about in the contextual understanding. So there is a, so I am sitting at the dash of the river. You're trying to guess the word bank from I am sitting at the, this becomes the previous, this is the first direction, and dash, that is that dash to be filled by, what do you say, a bank of the river becomes the second direction. So that is why you are saying the word as bi-directional. Okay. So I think more or less it makes sense to all of us, right? I think I just, yeah, got it. So that's what we are talking about. That's why you use the word bi-directional. Okay. So where is it? It's forward. Yeah. So, guys, just to talk about, I think now you can, if, now that we have understood everything, can anybody help me visualize what is happening here? Did everyone understand this portion? Let me zoom on this so that you can understand the context, what I'm referring to. Can anybody break this figure which I have drawn here quickly? इसमें आप लोग को समझ में आ रहा है क्या हो रहा है इधर?
This must be a cross embedding versus the dimensions we are having, right?
Right,
Cross
sir.
embeddings of
Exactly.
boy, man, woman, girl, bird, and dimensions.
Exactly.
Values,
Exactly.
final values, right?
Exactly. Yeah. So
Very,
exactly.
very
Exactly.
clear.
Exactly.
Very
A
clear.
group of vectors, what it has happened depending on the context.
Right. Exactly, ma'am. You're right about it. Right. So if I talk about, right, I use the word
But
boy. Yeah. Yeah. Tell me, sir.
so
Saying
this
something.
is not that our sine and the cosine relationship, right? This
No,
one
no,
is
no, sir.
different.
This is a
Yeah,
very
yeah.
simple one. I mean, this is just a representation.
Very,
You can, yeah,
yeah,
exactly.
yeah, right.
Yeah, right, sir. So if you talk about, you can see the this axis. Everyone can see this axis, right? D1. So I think D1 goes till D50, right? If you look into, right, D46, there's this ending at D50. So there is that, right? And you have each of these numbers representing. So D1 has some representation for boy, for girl. I mean, for that boy, again, the representation in second dimension, so and so, and so and so forth. You can see the stuff. Clear about it? I think more or less it's understandable by everyone, right? Some vector space visualization to understand, okay? So how to put in perspective of higher dimension, okay? So I think more or less you can understand. If I were to talk about, right, GPT-3 in specific, you remember, right? How many dimensions I told? 12K dimensions, right? So for boy, you'll have B1 till 12,288 dimensions, and you can represent it in the vector space if I talk about. Clear about it? Yes or no? All of us understood the concept here behind,
Okay.
right? So that is
I think
what,
in
yeah.
short, Saumya, we can say the instantaneous value for like boy, like men, like woman,
Yes, sir.
like that we can say
Exactly.
like,
Exactly. So
yeah.
you saw that 50 dimension with globe vector, which I showed you, right? That is just the representation here. That's it. For 50 dimensions. That's it, right? So if I talk about in a singular line, if I talk, right? So where dimension becomes the x-axis and the values become the y-axis. So I'm just representing those values, right? So to show the fluctuation, relative fluctuation between the stuff, right? Perfect. Perfectly iterated by Raja sir, right? So if I talk about each word is a whisper to Ravan's mind, but the head needs to hear vectors and not the languages if I talk about in the context. So in a way, if I talk about, right? So
And these are, I guess, this must be the
sir,
raw
just
values
one
only, right? Yeah, yeah.
Yeah. Sir. Yeah, you're saying something. Sorry.
This must be raw values only, right? These are not
Exactly, sir.
exponential values, right?
Yeah, these are
Uh,
raw means, sir. I should
hmm.
not say raw, meaning
uh,
Globe trained raw vectors, right, sir?
yeah,
Globe
globe
50
trend
trained
raw
raw.
values.
Yeah, exactly.
Because exponential
Exactly.
values could completely look like more than
Yeah,
1.5, I guess.
exactly, sir. They
It
will
will be
never
very
look
big.
like this. We'll go step by
Yeah.
step just to give them an idea that, okay, because see, sir, my intention was, since keeping things in graphical perspective is much more intuitive than talking about bigger numbers, right? It is very
yes.
easy to talk about. So that's why keeping it in perspective. So there's just a natural representation. That's it. Perfect. Now let's move forward. Okay. Now let's go into the details a bit. Okay. So you saw that I think more or less we can understand, right? You can see the title here. See, I'm taking two sentences here. Okay. First of all, I would like all of you to tell me what is the difference between these two sentences. There are these two sentences, right? What can you make out of what you say? Let me use the blue color and maybe sorry, and I say sentence one, and I call this as sentence two, right? So I think more or less you can see, right? There's sentence one here and sentence two, right? So what is different in these two sentences? Can anybody
Like
tell
you
me?
are asking about intention or just
Yeah, yes, sir.
meaning
So
intention?
what do you mean by sentence one? What am I saying in sentence one, sir? That's what I'm saying.
Yeah, that means the first sentence, like Saumya is getting some training, like learning from the trainers.
Okay, sir.
And
Okay, sir.
next one, like the way now you are doing, you train us daily, like that.
Right.
Like trainers are
Exactly.
getting information from Saumya, I think, if I'm not
Right.
wrong.
Exactly. Perfectly. Anyone else? Perfectly said by Raja, sir.
Yes,
Do all
Saumya,
of us agree?
here in the sentence one and sentence two, the words are
Right.
similar, but the sentence structure is different, the
Right,
formation.
exactly. And in fact, the output meaning also differs, right? Just like how Raja sir said, right? Just like how both of you added up. Number one point, just madam added up, Uma madam here, she added that the words changed, right? But and number 2 point, which was raised by Raja sir, that both of the sentences contain the same exact words, but the problem is, I mean, I am meaning something different in both, right? The first one says trainers, meaning this was actually, I took this example because we started this training and this was the context which I thought of, right? So we had many different trainers. So thankfully, I got trained from them, right? That is what sentence one means, right? Like Jay sir, we had training from Raja sir, right? So many of us, Ankit Paji sir, right? So we had a lot of training from them, right? And then the second one is, I say that I am training all the trainers daily, right? That's what I'm talking about, right? Having the same exact words, okay, but they mean different, okay? So I mean, now can you think of a solution to this? What is missing? You saw that I was okay. As per the globe which you saw, right? Do you think the word trainers, right? I think if I talk about, right? By the way, let me introduce you to a formal concept, right? Each of these words, right, is formally referred to as a token. Okay, I repeat myself, each of these words is formally referred in the space of transformers, or in fact, if I in the space of, even with the in the space of NLP, if I talk about, right, we all know about it, right? So these are word tokens. I should specifically say that these are word tokens. Okay. Everyone got the clarity, right? So how many tokens are there if I say about the words, right? Can anybody tell me in sentence one how many tokens I have? It would be
Four.
four. Exactly. Yeah, exactly. So same goes to sentence two as well, right? There are four tokens, right? Okay. Now, if I talk about the next thing, like for example, now you saw me earlier using the globe vector, right? And you saw that the globe vector, right, has a representation of the what do you say? Has a representation of the words, right? If I talk about, right? So in the context, I think you can understand the word trainers, whether it is here or whether it is here, will have the same set of numbers for both of these sentences. Will you all agree with me? Given the visualization which I showed it to you earlier, right? It will have the same set of numbers, same set of 50 numbers to be more exact, because the dimension was 50, right? So each of these words, right, if I talk about, right, so will have the same set of numbers. Don't you all agree with that? Yes or no?
Yes, yes.
Yes. Did others also get the understanding of the same? Why am I saying that, right? Both the word trainer here in sentence 1 and sentence 2, both of them will have the same exact, word embedding if I talk about, right? Same way you have train, right? If I talk about, right, in the context here, right? But in here also, okay, by the way, there is trains here. I'm sorry for that, right? There is one more introduction to the word here, right? However, there will be a little bit difference, right? If I talk about, because we saw that train and trains are pretty much very much similar to each other if I talk about, right? So you can take in total of 5 tokens if I talk about, right? So suppose in the context, let me remove train here, okay? Trains here for easy contextual understanding, right? Still, if I talk about Saomya train trainers daily, if I talk about, it is still the same thing if I talk about, right? But the meaning changes here, right? Same way if I talk about train. If I talk about daily, you have daily, right? If I talk about, right? Yeah, Raja sir, you have raised your hand. Yes, please.
Yeah, yeah. In
Yes,
my
sir.
point of view, if you are talking about context based, then maybe the values for like first sentence trainers and second trainers sentence may vary. I'm not sure about that in basis of context. Okay, context
Sir,
based if
yeah,
you are moving. Okay,
exactly,
but
exactly.
if you are moving only the word, only the
Uh,
trainer's word, then
right.
the vector values may be same for sentence one trainers and the sentence two trainers.
Yes, yes, sir. Sir, actually, I think, sir, you have summarized everything what we are going to cover in the context here.
Soumya, give me 1 minute. Sorry,
Yeah.
actually my Bluetooth speaker gone off. Just give me
Okay.
1 minute.
Yeah. Yeah, sir. Yeah. Anyone else with any other perspective here? Anyone else would like to add up? Yeah. Anything else which you think of, maybe?
Uh, as sir said, it would be same, I guess, but we have some difference in train and trains. So
Yeah,
that can be
exactly, exactly,
yeah.
exactly. So let me do this, sir. Imagine that there is no trains here. It is only train. Okay. So I think grammatically also it makes sense. Trainers train Saumya daily. Saumya train trainers daily. Right. If I talk about, right, there will be a little bit of a grammatical inaccuracy, but still it doesn't matter, right? So in this context, suppose there is no s there. Okay. Aman sir, you would agree that all four will have the same kind of a embedding, right? Word embedding, right?
Soumya, I'm
Yeah,
back.
yeah.
Actually, I'm
Yeah,
able to
yeah,
hear you now.
yes,
Yeah,
sir.
I
Perfect,
missed
sir. Yeah.
you like what you said.
Right, sir.
Yeah.
Sir, actually, our friends, sir, Aman sir was trying to add up something here, right? So he mentioned that he feels that trainers will have the same kind of an embedding, unless I just said that S should be removed for the context here, right? Sir, actually, what I wanted to say is you summarized it well because what happens, right? That is why globe is different. The globe representation of numbers is very different from BERT as well. Okay, because the reason is BERT is using transformers to get it, which has contextual meaning as well. The embeddings which you get from BERT, the output embeddings which you get from BERT, right, has contextual meaning as well, and that makes it different from globe. So that is what I wanted to focus on. Frankly speaking, Aman sir was right about it here as well, because in the context here, if I just talk about let's say globe, which we were earlier talking about, right? Trainers, irrespective of whether it is represented in sentence one or sentence two, will have the same kind of an embedding. Train will have the same kind of an embedding. Consider this train and this train. Okay, without the s, right? So Saumya will have the same kind of embedding as here as well. So daily will have the same kind of an embedding here as well, right? So the idea is, right, the idea here is there is something which is missing here. Okay, so it's not just words which you should fill in. Okay, there is something very important which is called as position. Okay, meaning where is that word located in a particular sentence, meaning this word relative to this particular sentence is located at position number 0, right? Whereas this word trainers, right, is relative to this particular sentence is located at position number 0, 1, 2, right? Are we getting it? Is it understandable by everyone? Are we starting
Yeah,
to
yeah.
understand and imbibe what is going on? Perfect, sir. Perfect.
Yes.
Exactly. So, sir, that's what makes transformers really very different if I talk about, right? Now, let me go ahead, okay, and talk about, right? So that's why this, the overall sense is the missing order, the positional encoding if I talk about, okay? So remembering order or injecting meaning into sequence, right? If I talk about. Now, let's talk about the problem, right? Attention. The attention mechanism does not have order sensitivity. Attention, when you see inside, when you go inside, I'll talk about more into attention, okay? It does not have order sensitivity, okay? You have to feed the order sensitivity first to the incoming stuff, right? And that is why, let me tell you, that is why, let me tell you here, guys, okay? In this picture, let me use red color, the one which you see here, the yin yang kind of a symbol, right? This is the positional encoding. Okay. This is the positional encoding. Okay. You provide the input embedding. Okay. They get added up. Okay. And then can you see this? Then inside the architecture, you are coming up with the word attention. We are going to talk about attention because it is in a step further. Okay. But you should understand, right? Attention by its own nature does not have any positional sensitivity. It has to acquire positional sensitivity from the beginning. Is it clear for everyone? Understood? Am I making sense to everyone? Is it understandable? Okay.
Yeah.
Yeah, perfect. So now, obviously, you might be wondering that, okay, fine. It's very easy to talk about the position, right? But how would you convert it into a matrix, right? The context there, right? That is what is challenging in the context here, right? So you have these few things, right? It lacks order sensitivity, right? So the obvious solution is what you're going to talk about, add positional encoding, which basically preserves, number one, word order, right? Encodes the positional information as to where this is located or that is located or whatever, right? And it enables sequential understanding as well, right? If I talk, obviously, now that the only thing is, if you provide position, it enables by default, okay, I know which word comes next to which word, right? That is how the machine will think, right? Because obviously, machine does not know what is train or trains, right? You're not giving any context to that in the context there, right? If I talk about, right? So by the way, just to add up here, right? I have a few tokens here, right? I told you about the tokens word, right, a while ago, right? So just here, hi all, welcome to the Transformers class by Saomya. There's a particular sentence, right? If I talk about, right? Obviously, you are breaking it into words, right? If I talk about, and now if you can see, right, each of the words, right, is, this number. Can anybody tell me what are these? Anyone would like to say this? Someone who might be aware of it. What are these numbers which I'm writing here?
Dimension number.
No, sir. Okay, okay. Sir, actually, if you talk about dimension number, this is a very big number. Can you see this? That
Yeah.
way you go out of the bound of the dimension. Right, sir?
Okay.
Yeah, right, sir. So, I mean,
I think
I'm
it's
happy that you
kind of
tried.
a tokens,
Huh.
the tokens that we are
Yeah.
generating and we are converting into
Sir,
some
actually, yeah,
terms.
you're right about it. Like this, how you talked about the tokens which you're generating. These are the words, right? You remember, right? I think Sir has already mentioned in our first classes when Raja Sir and others have taken the
Word
session, right?
frequency. Word
Uh,
frequency.
no, sir. This is
ID number.
basically ID number. These are the ID
Yeah.
numbers. Yeah, exactly. Right,
Okay.
sir. Yeah, madam. Thank you so much. Brilliantly said. These are the IDs, right, sir? So you need like male being represented by 0, or maybe female being represented by 1, or trans being represented by 2, something in those lines. So same way, you have these token. These are nothing but, frankly speaking, they are called as token IDs, right? If I talk, right? So each of the token contextually referring to a ID, right? So there are 9 token IDs. I think 9, 2, 4, 6, 8, 9. Yeah, right. So 9 token IDs. I mean, see, let me tell you one more thing here. The actual tokens are not exactly like this. I'm just for very simplistic view, I'm showing it to you this in this manner. There is nothing called as a Saomya token in chat example, GPT example. Okay. So in fact, do you know how many tokens are there in GPT? Now that's an interesting question to ask here. Anyone would like to say how many tokens are there in GPT-3 specifically? If I talk about anybody, any guesses? Any guesses? Yeah. Yes, sir.
I think yesterday we had learned about that. It was 12,288,
Sir, that
right?
is no, sir. That is dimension. The one which you say is dimension, meaning each token represented in 12,288 numbers. Each of the token being represented in 12,288 numbers. Got it, Aman sir? Right?
Okay, okay.
Okay. Okay. Now, how many how many tokens are there? Any approximate guesses? I'm happy, Aman sir, give it a try. Anyone else?
Nearby 2000.
Okay, sir. Okay, it's actually way bigger than that. It is just 25 times of that, sir. So you said 2000. So the total number of tokens
25,000.
approximately, yeah. No, sir,
50,000.
50,000. Yeah, yes, sir.
Okay.
So the total number of tokens in GPT-3 specific, right, is close to 50,000. In fact, it is a little more than 50,000, but that's the whole idea. Okay. So the total number of tokens, and if I talk about in the context, okay, just a interesting quick knowing fact. Okay, that's the whole point. Now let's move forward. Okay. Okay, now here's the thing. Okay, you know the entire thing. Okay, you might be wondering, right? So first, you should understand one thing here, right? Let me elaborate this a little bit further. Okay, do I have this here? Yeah. So let me elaborate this a little bit further. Okay. So you see that word embeddings. Okay. You saw the word being embedded. So suppose for our realistic point of view, or maybe forget about, let's take that globe 50. Okay. Globe 50. So it is being embedded in 50 dimensions, right? So x1, x2, x3, and so on and so forth till x50, right? If I talk about, right, that is being represented, right? So the idea here is, let me tell you how transformers. You saw that diagram of transformers. What happened? Yeah, you saw that diagram of transformers where you saw this, right? There was this positional encoding, and that was getting added to this particular stuff, right? That was word embedding, right? If I talk about, right? And both of, in fact, I have the word embeddings here. So I should, maybe I'll use this word here as I'm adding this up here. Okay. So I add this positional encoding and word embedding together. Okay, and I pass it to the transformer, right? Or multi-head attention and stuff, whatever, right? You saw that diagram, right? What do you say? Obviously, like you saw that, right? In the context there, right? You have 50 words, 50 dimensions here, right? So to match this word embedding, the positional embedding also, understand this word, guys, okay? The positional embedding must also have exactly 50 dimensions, P50. Do you get it? So that at the end of the day, what you just do is do an addition operation, okay? And you get whatever in the context here, right? You added x1 plus p1, okay? Then you have x2 plus p2, okay? And so till x50 plus p50. Do you get it, guys? Right? This becomes the input of the transformer here. Is it understandable? Is this concept clear? Just a little bit to understand the contextual understanding here, right? Is it understandable by everyone, right? So the idea is it should have the same exact dimension as that of the word embedding, so that we can easily add it and just put it forward to the next layer to look into. Okay, now you got the understanding of it, right? Now how that happens internally, if I talk about, is through this guy here. Let me use this here. Okay, come on. I won't go in depth on this. Okay, I'll just talk about it a little bit so that we have an understanding. Okay, so the behind the scene, how it works out. Okay, you have POS, you can see the position in the sequence. Okay, right? There's a formula here which it talks about, right? You see that there is main component here is the sine and cos variant, if I talk about, right? So in the context here, right? So you will understand why sine and cos is being used. Let me go to the next, okay, slide to show it to you actually. Do you see this left representation, everyone? I'm not sure whether it is visible properly, but let me, oh, I'm sorry. Let me just use, come on. Yeah. So guys, just focus on this a little bit. Okay. So you can see the sine values. Okay. I think everyone understands one thing here, right? The best thing about these values, right? They exist. If I talk about, right, the values exist between +1, right? Rotates between 0 and -1. Same way, it is just a unit circle, right? It is a unit circle, right? Where you have these positions in the context here, right? So this is actually a phase diagram. This is also called as a phase diagram, right? Used very popularly in mathematics to show up because there are two different, because if you talk about, right, you want to see how the phase changes. Okay, so if I talk about in the context, right, you see a nice neatly drawn circle, right? If I talk about, right, and these circle points are coming from this point here, which you can see here, right? You are basically projecting this point. A phase diagram is just a projection of this point, right, which you see here, right? It is being projected here versus the point which you see here, right, getting projected here. So I think you can understand in a two-dimensional plane, in order to represent it, right, you need a x and a y coordinate, right? These x and y coordinates are coming from the cos and sine. When the cos value reaches, I mean, whatever the cos value is at this point, whatever the sine value is at this point, right? If I talk about, they are getting represented in the form of a circle. Why is it circular? Because you saw that the cos and sine both, what do you say, revolve between -1 extreme ends to +1, right? If I talk about, right? Similarly, in the context here, the sine value also revolves between here -1 to what do you say? Sorry, +1 to -1. If I talk about, is it understandable? All you are doing is taking that point and projecting in a circle, projecting here, right? You take those infinite number of points together. Guys, sorry. Is it audible to all of you? I think there's some construction work
audible.
going on.
Yes, yes, you are audible.
Yeah. So I think more or less you can understand that this exact point, you can see the points fluctuating between -1 and 1, right? If I talk about, same happens here as well. You can see -1 and 1, and you can get a perfectly drawn circle here, right? If I talk about, right, it will obviously trace the same circle over and over again, right? If I talk about, right, and this is the exact reason why you use this point, because let me tell you here, right? Sine of any number, let's break down this formula a little bit. Okay, sine of any number, obviously, even if it is a very big number, right, or very small number, I don't care what is happening inside, sine of very big or a very small number has to rotate between -1 to 1 in the extreme ends. Is it clear for everyone? Yes. Is this point clear to everyone?
Yeah.
Yeah. Same goes for the cos, because cos x, again, if I talk about, right, in the context there, right, also revolves between the -1 and 1 to the extreme ends, right? Whatever whatever cost value you get, right? You do this operation, you get 0, right? Cost 0 is 1. What do you say? You do this operation, you get maybe 1,000, right? I don't know, cost 1,000, whatever it comes up. Obviously, you'll end up getting a number between -1 and 1, right? If I talk about, right, in the context there, right? So in the relative terms, if I talk about, irrespective of whatever the value is, right, inside this, right, you are going to rotate between -1 and 1. Okay, so the best thing, the reason why you are doing it is you do not overshoot. Okay, whatever you are doing, whatever representation you are making exists between 0 and sorry, -1 and +1. Can I get some thumbs up if this particular stuff is clear? What is happening, like if I take sine or a cos? Is it understandable? Okay, perfect, brilliant.
Yeah.
Next, yeah, let's move inside now. Okay, so we have POS, right, which talks about position. Okay, you can see position in a particular sequence, right? That's what is in the numerator. That means, obviously, if I say Saomya trains, I mean, trainers train Saumya daily, right? The word trainers will have a position number as 0, right? The word train, what do you say, will have the position 1, right? Oh, sorry. Yeah, train. And maybe the word Saumya will have position 2, right? And the word daily will have position 3. Is it clear for everyone, right? So you put the positions on top, right? If I talk about in the context here, right? And then you can see here, right? It's a little bit complex to understand, right? So in order to understand this, right, you see that there is a factor here talking about 10,000. It's not actually a random number which they have taken here, right? It ensures stability. Okay, so because the fact is, right, you could have chosen a very smaller number, like let's say 10, right? But the number of points which you, decimal points, accurate decimal points for representing it on a circle will become fairly very less. So there will be competition among tokens to get represented. Okay, because there are many number of tokens, right? And if I talk about, right, so there are in theory, right, if I talk about, right, you have like GPT-3 has 50K tokens, right? On contrary, if I talk about other models, bigger models, they have like 1,24,000 tokens, right? So something in those lines, right? So in order to balance that out, you have an optimum number. And by the way, you might think of like you can have a bigger number, like let's say maybe 1 billion, right? One followed by nine zeros, right? If you take that, right, it will be way more precise, and way more precise will again result in confusion. Okay, there might be two overlapping points which might lead to overall confusion between the context being described in the stuff. Okay, so I'm just giving you an overall idea about the context here which we are referring to. Okay, and by the way, let me tell you one more thing. You can realize that there is 2i here, or in fact, forget about the number 2 here for some time. Take this as I, and or in fact, you have this 2i plus 1, right? Where have you seen this reference? What do you I mean, I think you can understand in the context here, if I talk about, right, this, if you look into, represents the odd and even contextual understanding. You get it? That means dimension 0, then dimension 1, right? If I talk about, right, they form one pair. Okay, then you talk about in the context of dimension 2, dimension 3, they give one pair, right? If I talk about, and where are these two pairs coming from? One pair is a sine pair, the one of them is a sine pair, the other one is a cos pair, right? Because you need two numbers to represent it in the form of a what do you say, circular dimension, if I talk about, right? So in the context here, right? So I hope it's particularly understandable. That's what is happening in this context here, right? And you can see the dimension of the model here, right, which is getting what do you say, so guys, I think everyone understands. Let's do a little bit of math here to understand the contextual significance. Okay, let me take this. Okay, so guys, can you tell me what will happen if this entire factor turns out to be 0? What can you tell me what will happen this if that happens? Whatever that is becomes 0. What will be what will happen?
Values should become 1, I guess.
Yeah, exactly. You are right. It is saying 10 to the power 1, 2, 3, 4, right? 10 to the power of 4. And on, I'm saying that it is raised to the power of 0. If I talk about, right? We know that anything to the power of 0 results in 1, right? Just like how you described it perfectly, right? So if that
Yeah,
factor
just
turns,
one. Yeah,
sorry,
just
sir.
one. I want to add just one point here. What
Right,
we
sir.
have here, we are having 10,000 to the power of 2y divided by the dimension of the model. So
Mhm.
if there is actually one fact about it, whenever this the model value, the d value, if it becomes like by mistake, if it becomes 0, or by
Uh-huh.
mistakenly anybody has put there that it is a 0, so that is
Exactly.
never possible. So
Yeah.
whenever the 0 value happens here, it becomes very,
It's
an impossible number,
convenient.
and it, yeah, and it also, like it tends to no parallelism, like no parallel context to any other
Ah,
words also. So
right.
the relation doesn't actually, we cannot see the relation in the graphical way also here.
Right, exactly. Perfectly. Nicely said, sir. Yes. So if just like how sir has mentioned it perfectly, right? Whenever this term turns out to be what you say 0, right? It keeps a stability, right? Anything to the power of 0 turns out to be 1. That means only you are left with position. So sine of position. That is what you are going to get, right? Can you tell me, guys, everyone, okay, what is the value of position in the first case? Can anybody tell me value of position in the first case here? I talk about trainers train Saomya daily, right? What is the value of what is
1.
low? So I start with zeroth index here,
Okay. So
right?
it will be
Okay.
0.
Exactly. For computer scientists, sir, one thing to be kept in mind, they were cracked head, so they started with 0, sir. And I think, sir, you can see the big advantage which we have if you start your number line from 0, right? A lot of things become conceptually very easy to get it. So if you see sine of POS by 1, this factor was turning out to be 1, and POS is nothing but 0, right? So I think you can understand sine of 0 is what? Everyone, what is sine of 0?
0. 0.
0. Exactly. So, irrespective of whatever lines I take, right? You see, trainers train Saumya daily. There is another one which I've taken here. Hi, all. Welcome to Transformers class by Saumya, right? The first word hi, right, is, for contextual clarity, I'm representing let's take for easy representation, I'm taking 4 dimensions, okay? Let's not talk about 50 dimensions. It's very difficult to picturize, right? Let's say only 4 dimensions, okay? So in this context, can you see here, there is a nice graph which I have given here. So for D1 or the dimension 1, if I talk about, can you see this red line? The red line, the pointer first points towards the number 0. You got it, right? So that, because this will happen irrespective of whether you take this, what do you say, this set of sentence, or you take this set of sentence in this context, which we are talking about, okay? So whatever you take, right? So that gives the first one or the first position to be described in the context there. Clear about it, everyone? Yes or no? Understood, right? Yes, yes, no, maybe. All right, perfect. Now, I told you one more thing, that if there is a sine pair, right, you saw that rotating circle, right? For a consecutive sine pair, you have a cos pair, right? If I talk about, right? So that you can represent the things, right? So that is why the entire word sequence, I told you, right? I'm trying to represent each of these words in 4 dimensions, right? This is dimension 1, 2, 3, and 4. Okay. So the first dimension becomes 0, right? I told you that it exists in pair. That means these two exist in one pair. Okay. That means I have put 0 on top. Okay. That is the first one, if I talk about, right? Same way I put for the second one. Okay. Again, because I need the consecutive pair for cos as well. Is it clear for everyone? Right. So it exists. So there are in total 2 pairs. Why am I saying 2 pairs? Because one pair is this, The second pair is dimension 3 and 4. So I've just, for easy simplicity, I've taken 4 dimensions. What will happen if I take 50 dimensions? So same way, you have that. The first 2 dimensions refer to 1, right? Second, I mean, 1, 2 will refer to 1, 3, 4 will refer to the second pair, right? 5, 6 will refer to the third pair, 7, 8 will refer to the fourth pair, and so on and so forth. Can you tell me how many pairs will be formed in that case? How many pairs will be formed, guys? For
25.
4, sorry, sir?
For 50, it would be 25 pair, and for
25.
4,
Brilliant.
it would be 2 pair, right?
2 pairs.
So if
right?
we are having 2 pairs, so it will start from 0. The first pair will be 0. Second pair will be like first number will be 0, and second number will be
Sign
1.
of that. Sign of that, because you are talking about this is sine and this is cos. That gives that completes 1 pair. Then again sine, then cos, right? Second pair, third pair, sine and cos. You get it? You understood, right? Yeah, I mean, I think the analogy is clear a little bit, right? So the math might look a little bit complex, but in the inherent space, it is doing the exact thing which you expect it to do. Okay. Now let's consecutively let's look at it. Okay. Now I told you, right? So sine position 0. You saw you got the value output as 0, right? Same way I have to do it for cos as well, right? We just discussed about it, right? Cos of 0. What is it? How much is cos of 0?
1.
Yeah, exactly. Let me go to this here. Okay. Brilliantly said. Can you see this here? Now let's go to, you saw the first dimension, right? That was represented in red. The second dimension being represented as black. Can you see this value here? Right? It starts from 1. Do you get it? Is it clear for all of us? A little bit. I am not saying that we are getting pros in, what do you say, transformers. It's just, oh, I'm so sorry. What did I do that? Yeah. Yeah. Perfect. I think more or less we are able to understand what is going on. Okay. Now I think you can understand for what you say for the next set. Okay. Again, you take the sine and cos value pair, right? So I think you can understand we are representing. I think I just described it to you earlier. Let me rub this hole off. This is looking very pathetic to look at. Okay. Now, when we sum it all up, you can see, I told you, right? I'm trying to represent this guy here, every word, okay, in 4 dimensions. Okay. I want their positional embedding. Okay. You can see this here, right? So the first pair is the red one. Then comes the black one. Okay. Then, because I told that 4 dimensions, again, the thing repeats if I talk about, but in the context here, the third value, if I talk about, right, again, is exactly the same, because again, you wind up getting the same particular value in the context there. And if I talk about the fourth one, again, relatively the same. If I talk about, as you go on doing it for what you say, different values, right? Hi, all, right? You have welcome, right? You can see the relative positions, right? Two, right? If you talk about, right, you have a nice sine cos curve which fits the entire agenda into perspective. You get it, guys, right? So, and you know how it is treating the position here, because you see that it is not an exact number lying between, exact number always like 0 and 1. You get some other values as like maybe 0.1 sorry, 0.01 in the context. I'm not sure whether this one would have it. Let me just put it here. I think, guys, can you see this here? When I hover over there, can you see the point D3? Is it visible to everyone? Not sure. I'll probably zoom in here. Is it visible? Yeah, perfect. Perfectly said. Thank you so much. So you can see for POS, you can see the value, right? For you can see it is showing up as 0.01, right? It comes up for the black one, it shows 0.54, right? So it, because you are fitting that in this formula, right? and then you are getting the position based on that, right? And I think you can understand why you understood the intuition behind having sine and cos together, because both of them refer to the phase, right? This will be little more clear in this particular diagram if I talk about. Let me elaborate this a bit. Here on the left hand side, you can you see sometimes it bothers me like anything. Yeah, so you can see the phase diagram, right? You have one phase for cos, one for cos and one for sine, and you're representing it in the form of a circle, if I talk about, right? And guys, look at this, right? You earlier saw that I was representing this in only 4 dimensions, okay? I was representing it in only 4 dimensions. What will happen if I take the same set of numbers, same set of input and try to represent it in 16 different dimensions, okay? So this is for 16 different dimension on the right hand side. You can see here, right? Can you see this here? It shows dimension 0, 1, 2, 3, so and so till dimension 15, right? You can see 8 of them. Can you see this here? 8 of them. I think you can even count. I'm not sure. 8 of them would be coming from sine, and the other 8 will be coming from the cos position. Do you get it? Is it understandable? And there is one more interesting observation you will make, guys. Look at this. There is one more very interesting observation which I wanted to talk about here. Look at this. As you are reaching towards the end of the dimension, can you see this? Towards the end of the dimension, where you are talking about dimension 15, 14, 13, can you see the curve? Can you see the relative curve? What is happening to them? Can anybody try to? Sometimes I get frustrated with this. Yeah, I think I'll be able to show it here. Can anybody tell me or interpret what is going on here? Look at the colors here, guys, okay? And look at the dimensions here, okay? And tell me what interesting pattern do you observe in this stuff? Anybody? Except for Aditya, sir. Aditya, sir.
Okay.
I know, sir. You will be able to tell me. I know, sir. Yeah. So, anyone else? Sorry, sir. Sorry for that. You can clarify it more, but first I would like someone else to try.
We already have discussed like this another scenario as well. Like for me,
sir.
that was for the cat's hat, and for 50 dimensions, like it was combination, not even permutation.
Exactly, sir. Yeah. So yeah, guys, please, anyone would like to tell me what is trying to happen as what pattern do you observe here? Anything? What do you think?
Can we see the x and y values?
See this value, sir, right? I think
yes, like
I think I'll just come on. Is it now visible completely as well, sir?
Yeah. Thank you.
No worries, sir. Anybody, whatever you think, what is happening here?
So we can see that from this picture, the dimensions are circulating from -1.
Right, exactly. Perfect.
Yeah, and apart from that, we can see there are few of the things, few of the dimensions which are starting with 0, comes under the sine value, I guess.
Yeah, exactly, sir. Exactly.
And
right,
yeah, and
nice.
that's all I can recall from this.
Awesome, sir. Awesome. Nice try.
Some of the encoding values are linearly incrementing.
Sorry, madam.
Between the words. No, I was just mentioning it is like, can you hear me?
Yeah, I can hear you. Yeah, I can hear you.
No, the encoding values for the word, the alignment. So if you see, for all the words, there is a connectivity between from 0 till the last word. Some are being in a linear incrementation as a line, and some have between there is another curves which is mentioned for the same like words. So for the same sentence of words, you are able to see multiple lines of curve, and some are linear and some are non-geometric.
Okay, okay, nice, interesting observation. That's great.
Yeah,
Yeah.
yeah. And one
I would like
one
to
line is
add.
also like looking like a parabolic, I guess. So it's
Okay.
not like we cannot see that like normal sine cos waves. It's not looking like normal sine
Right.
cos waves. Yeah.
Yeah. Okay. Okay. Brilliant.
So
Brilliantly said,
that's
sir.
what we are
Nice.
observing. Yeah.
Nice observation. Yeah. Someone else was also trying. Perfect.
Also, Aman sir,
So
try to see the pattern when these dimensions are increasing. Also, try to look at that as well.
so that's what the lower dimensions kind of have something longer,
Um, yes.
and
Yes.
when it's higher
Yes.
dimensions, they have shorter
Exactly.
wavelengths.
Exactly.
And
Exactly.
as Aman sir said also that sine function is for the even number and cosine is for the odd number.
Yeah. Exactly. Right.
Uh,
Brilliantly
so
said, sir.
it's it's kind of
Nice.
giving the position, right? We are speaking about the
Ah,
position since transformers do
exactly.
not have that what to say, you can say that convolution, so
Mhm.
they keep so they need a they need a way to understand the order of tokens.
Represent. Yeah. Exactly. Need
The
a
transformers
representation.
need that. So yeah.
Perfectly said, sir. Exactly. So to compile everything, just like how also even mentioned by Aditya sir as well, right? If I talk about the overall structure, which you can see, many of these things have been clarified. If you look into, right, the lower dimensions, number one pattern which you can observe, right, they fluctuate more, right? If you talk about in the context, the dimension 0, right, that is represented by brown, right? If I were to trace this curve, it looks like this, right? As and when, if I talk about, right? Similarly, as we talk about, as I increase, obviously, one and the odd dimensions, you can see starting from 1, right? But you can see that there is a, like if I talk about, there is a curve which you can see pretty much interestingly, which talks about in the context here, right? If I talk about, right? Irrespective of whether they are starting, some of them are starting from the sine perspective, some are starting from the cost perspective, if I talk about, but you can relatively understand. But as you reach the end of the dimension, as you are approaching the end of the dimension, you can see it gets flatter and flatter, right? This is the observation which I wanted to make here, right? Just like how everyone with their collective efforts, we were able to talk about, right? So you can see, right? It's so, but understand one thing, it's not that the last word is having some kind of a lesser meaning than compared to the first one. Yeah, Ankit sir, you have raised your hand. Have some questions. Uh, Ankit sir.
Actually, okay, sorry, you are not audible.
Oh, okay, okay. He's trying to speak, is it? That.
Ankit, I think your voice is not audible.
Yeah.
Still not audible, Ankit sir. You may need to remove your headset, earphone.
Oh, yeah, I think, sir. Yeah, I'm not able to. Oh, carry.
Carry on.
You just wanted to say
Okay.
carry on, I guess.
Okay, sir. Yeah. Oh. So, yeah, so that is the whole idea behind which we were discussing about here. Okay. So I think more or less it is understandable by all of us. Okay. So the relatively the lower the dimension, you see lesser changes. Okay. Sorry, more fluctuation. I'm so sorry. You add up more fluctuations. Okay. But as the dimension increases, okay, so meaning in GPT kind of a model, the more you are closer to the zeroth dimension, it will have a lot of fluctuating information. Okay, but as you try to go down in the matrix representation, okay, in GPT case 12,288, as you go below in the matrix chain, right, you will see that it is relatively, what you say, straightforward in the context of that. So what it technically means, that the vector, right, in a very higher dimension, right, suppose this is not a correct representation. Suppose the vector in initial dimensions, okay, it is able to fluctuate more. You see a 90-degree turn or maybe a 70-degree turn. Then there is, let's say, a 40. What do you say? Maybe again another 70-degree turn, right? If I talk about, right, so this is, let's say, dimension 1, dimension 2, dimension 3, and as we are approaching towards towards nth dimension, you will see very less changes. Okay, so this is again a big turn, right? But you'll see a very less change happening. Okay, so that's what I wanted to focus on, right? So the idea, the collective understanding is that these things, these few small things add up. So the last vector, last horizontal vector, if you consider it as a last horizontal vector, that means n of 12,288th vector will contribute less because its line will be pretty straight. If I talk about, the contribution will be very less compared to ones that are coming in front. Okay, so that way it adds some kind of a position. You can see, right? You're able to somehow attain the meaning of, okay, do more changes, fluctuate more in small when the value is small. As the small value gets bigger and bigger, somehow you are able to understand that it is keeping a track of something like a position which is trying to get imbibed in the meaning of it. Is it clear to all of us? Obviously, to see, guys, it is relatively very important to read the facts as well. Okay, so it is, and given the time constraint, we can't also go a lot into it. But yeah, yes, sir.
I just want to add something here.
Yeah, yes, sir. Yeah, yes,
in
sir.
the comment, Medini has said like that will be mostly near to the zero line. The thing we are having here is like as we are talking about the dimensions here. So dimensions basically it is for individual dimensions also, we can say, like the basis as we had discussed yesterday as well.
Yes, sir.
So let's say one base is there for dimension 1, another base is there, the second base, which is for the 2-dimension words. There could be 3 and n dimension and n bases. Basis means the Cartesian graph only. Okay, let's say you are having a 3D Cartesian graph is there, like this one. So this is for the dimension 1. So you can have another one also,
Another
like
one.
this over here. Yeah. So this is how we are actually building the relationships. Okay, Medini, we are actually building this like this. What we just need to do, we are taking the relation between this one base as well as the another base as well. So that is why when these dimensions are increasing, it is going to zero, but it is not completely zero.
Completely.
If you are going to look it from the another perspective, let's say you are having this z-axis is there. In that way, that couldn't be zero. Actually, it could be some other value actually.
Exactly.
Yeah.
So
It could be quite confusing actually, but the thing is, part of matrices it is, and definitely it takes a time little bit to understand that.
Exactly. As perfectly,
audible
very
now?
nicely. Yes, sir. Yes, sir. We can hear you now.
Actually, at that point, na, as like sometimes like we are learning this NLP and all, so and we are also talking about the context. So, like that time, just like whether we are talking about the higher dimension or the at the end. So actually, these two are different things, na. So I just mentioning that part at that time.
Exactly.
So we are going to higher dimension, not the end of the dimension.
Higher dimension. Exactly. You are going to higher dimension, not towards the end. Sir, I said the end of the dimension in the perspective that you are reaching towards the end of the dimension, or whatever that n value you have chosen. So if you have chosen 100, that you are reaching proximally close to the nth dimension, right? Just like how sir has mentioned, are talking about. And it is a little bit difficult to visualize the perspective, but a very nice intuition given by even if I talk about Aditya sir as well, right? So the basis, if I talk about, right, it will help you to visualize the things in a little bit, but obviously takes a little bit complex understanding to the same, right? So that's why I kept it a little bit relativistic, simple
linear.
to understand.
Yeah.
So,
Transformation. Linear
yeah.
transformation.
Exactly, sir. So, okay. So, by the way, it is 11:41. Guys, you want a break, right? I
Yeah, I
understand.
think
Yeah.
we can
Uh,
come back by well.
yeah, sir. Sir, I'm really sorry, Aditya, sir. I will be taking the next half
No,
for
sir,
a
no.
little more time.
Sir, the thing is like it's going really great. And even I have a very similar content, almost the same content only. But the
Sir,
thing
you
is like
can
it is
just.
going
Uh,
really no, you take the complete time actually. I will shift to tomorrow's one because
let's
the
see, sir.
content I may have to change most of the contents actually because
No,
it looks
sir,
very similar.
sir, you can do
Yeah.
one thing. Like, I mean,
Hmm.
because they need a recap. I won't. Because, sir, when I am left with recap, right? You know, it.
Hmm.
I take a lot of time for that. So, sir, you can
Okay,
keep those
no
slides.
problem.
You can
No problem,
talk
no
it as a
problem. I
recap.
will
For,
change the perspective actually to the
yeah,
matrix
exactly. A
actually.
little bit.
Yeah, yeah.
Right.
Yeah, yeah,
Exactly.
sure,
Exactly.
sure. No problem.
Thank you
Take
so
your
much.
time.
Thank you. Okay. So, sir, guys, let's take a quick break. It's 11:42. What time do all of us want to return?
12, 12. It's already 11:45, I guess. Round off.
30. So 12 o'clock. Shall we return at 12 o'clock?
Yeah, yeah, 12.
All of us? Is it okay for all? Right? Thank you so much, sir. So my apologies again. I always think कि हो जाएगा यार, पर फिर उसके बाद I think that okay, if we are spending time, let's spend it wisely. So my apologies to everyone. So bear with me for a few more minutes and then
No issue,
so
no issue.
No problem, sir.
okay.
No problem. We will be here.
Yeah. All right, sir. Let's take a quick break. everyone. आ गए सब लोग? there.
Yes, yes. I guess, sir.
Yes,
Yes, sir.
yes, Saomya.
Sir.
I think next time, no,
Yes,
I
yes.
have to schedule in this way. First Saomya has to take, and next me.
Sir, if we are having Raja sir, if we are getting 1 day, 5 days should be given to Saumya sir. It should be 5 times more.
Uh,
But we are
the
loving
gain,
it, you know. We are loving
yeah,
it
yeah,
because this
because
content is really amazing. Like
yeah, yeah.
you can take a one session also, Saumya sir, like how to create this content because I really loved it.
Oh, sir, thank you,
Yes,
sir.
I agree with you.
Yes,
Yeah.
we
सर
need that
इसमें
actually.
इसमें बैठ के बहुत कुछ करना पड़ता है सर उसमें
हाँ, right.
हाँ, कोई
Yes.
दिक्कत नहीं है, बैठ
हाँ,
लेंगे,
कैसा
खड़ा
है
हो
कि
लेंगे,
मतलब
कोई दिक्कत
Because this is the first time that I have seen. If you can just move your cursor to, you know,
हाँ सर
हमारा मेरे ख्याल से साइन कॉस का था ग्राफ. तो you
हाँ
showed
सर
that dimension 3, हाँ D3 आपने दिखाया था. तो yeah, I don't know how to, you know, show this comment. Comment नहीं कहते इसको, कुछ
सर
कहते.
हाँ हाँ सर you know sir this is not a what you say this is not a plot sir ये कॉपी पेस्ट वाला प्लॉट नहीं है सर ये वाला
हाँ हाँ.
लेट मी टेल यू सर ये वो है ये वाला वो है लेट मी गो टू दिस ये आप देख रहे हैं
आपने
सर
इसको एक्सेल से किया है क्या
एक्सेल
सर?
हाँ हाँ ये
एक्सेल
एक्सेल
में
से है आप देख
हाँ,
हाँ
ओके 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 ओके.
इसीलिए सर हाँ तो बेसिकली सर इसका देर इज अ डेटा टू विच इसको ये
हाँ,
करके
एग्जैक्टली एग्जैक्टली.
तो
सौम्या
देर
सर डेटाबेस
हाँ जी
कनेक्शन किया है.
क्या सर सॉरी सर
डेटाबेस कनेक्शन हो रहा है ग्राफ का डेटाबेस से. Like Excel is the database.
हाँ सर एग्जैक्टली एक्सेल एक्सेल सर काफी हद तक इट रियली गुड कम टू रिप्रेजेंटेशन सर काफी आप अच्छे से
एक्सेल का इतना यूज मैंने बस अपने वीकली मीटिंग्स में किया है. वो वैल्यूज डाल के रख दो, वो पीपीटी में ऑलरेडी कन्वर्टेड रहता था वो.
हाँ सर
ग्राफ के लिए तब यूज किया था ना, जब हम लोग रिपोर्ट बना रहे थे तो
हाँ
हर
हाँ
कॉलेज का
हाँ
वो पाई चार्ट बनता था. तो एट
एग्जैक्टली
दैट टाइम बस
सर
बट दिस वन लुक्स रियली कूल. दिस वन.
हाँ सर एक्चुअली सर जो मेन ये है कि सर बहुत सारे थॉट प्रोसेस होता है फिर सर उसको ऑर्गेनाइज करके कि कैसे करना है क्या करना है ये बड़ा तीमझाम वाला
हाँ
काम है फिर उसके बाद ये भी
हाँ
होना
राइट.
चाहिए कि लोग सो ना जाएं हैं फिर प्रेजेंटेशन बना रहे हो तो भाई लिखित कंटेंट देख देख के लोग सो जाएंगे तो फिर
राइट
उसके
राइट.
बाद ट्रांसफॉर्मर जैसा टॉपिक क्या ही कर मैं समझ
हाँ
में
जी
क्या
हाँ जी
क्या
बिल्कुल.
जो दिमाग में आया बस
और
वैसे ही करके
अब ये तो बस पोजिशनल है, अभी तो मल्टी हेड तो अभी बाकी है.
नहीं सर मैं उसको उतना वो नहीं लूंगा सर थोड़ा सा ओवरऑल कॉन्टेक्स्ट में एक ओवरऑल आइडिया लेके विल टॉक अबाउट लेट्स सी सर
In fact, transformers have not been started.
क्या क्या?
हाँ सर यू आर
नहीं,
राइट हम अभी
Transformers
यहाँ
start
हैं
भी
सर
नहीं किया अब.
ये
हम यहाँ
हाँ
हैं
एग्जैक्टली
सर
एग्जैक्टली
हम यहाँ
We are in the
एग्जैक्टली.
Pokemon ball.
एग्जैक्टली सर बट सर फ्रैंकली स्पीकिंग हम सिर्फ इतना ही बात करेंगे सर टू बी फ्रैंक हम लोग सिर्फ इतना ही बात करेंगे मतलब आई विल बी टेकिंग इट अप अंटिल दिस मच ये जो चीजें हैं ना सर दीज आर ऑल यू ऑल नो अबाउट इट
आई विल कवर इट.
विल लुक इनटू
फीड फॉरवर्ड इज देयर. या रेसिड्यूल्स वगैरह आते हैं उसमें. या
हाँ
सो
तो उसमें तो वो है तो बाकी सब ये क्योंकि ट्रांसफॉर्मर्स का मेन आर्किटेक्चर जो है हेड क्या है वो वाला चीज थोड़ा बात करेंगे बट हाँ जस्ट लाइक पॉइंटेड आउट बाय आदर्श सर एग्जैक्टली अभी हम लोग नीचे हैं निचले हिस्से में हैं बट आई थिंक गाइज गिवन द कॉन्टेक्स्ट एंड पिक्चर विच इज कलेक्टिवली गिवन बाय आदित्य सर एज वेल एंड अदर्स आई थिंक मोर और लेस वी आर नाउ एबल टू विजुअलाइज and understand what is happening right so contextually इसको और भी अंदर तोड़ मरोड़ के जाया जा सकता है but As of now, I'm keeping it cut short here because that's the most important thing which is necessary here. And let's move forward and discuss about few more perspective, which I wanted to cover up. Hopefully, we all now understand the concept behind. Okay. And let's have next look. Okay, now guys, I think more or less everyone understands this. Okay, the final input form which talks about, that is nothing but words with, I think you can understand, guys. Do you everyone agrees to why am I writing this? Everyone, especially the ones who do not have any idea of transformers, why am I writing this word? Is it clear to everyone? Yes or no? I'm saying the final input form, I'm saying words with dash of their places. Is this clear to everyone? Why am I writing memory here? Everyone got the concept here, right? Yes, no, maybe others?
Because to
Yeah,
because for the order, right?
yeah, exactly. You got it, sir. Exactly. The position, okay, and the order in which. So thanks to this, what do you say? This matrix, right, which you get out of this, right? Thanks to this output matrix from here, right? You now have the original matrix, right? Or a matrix is that word embedding plus the position, right? Thanks to all of that, you now have a complete idea about what is going into the transformer, right? So input formation process, there is this word cat, you have word embeddings, so and so, right? Same, I told you, right? That exactly that embedding dimension, the positional dimension should exactly be matching to the word dimension. And at the end of the day, right, you get the final input vector, which acts as, what do you say, guide head as to what we talk about, right? Now, I think, guys, it is very interesting to note one thing, right? You are able to achieve so many things, right? Earlier, we just knew words, right? That how words are reacting to each other in terms of English and stuff, right? But the fact about all of this is now words being converted to numbers. Now you're able to see that numbers collectively can also put some bench towards what this particular word has to offer, right? So a little bit in terms of the position in place, right? Because guys, let me tell you one thing in the context here. Let's move forward and discuss about it, right? Now, the whole idea behind the perspective which we are discussing about, right? The idea of what is attention, right? And why should the machines care, right? So number one point, if I talk about, if you look into, right, human understanding, if I talk about humans, right, how humans perceive the things, right, we do not think things in a linear perspective. Linear means, okay, linear is very simple, right? You have a straight line, okay, at the end of the line, I know for a fact this is the answer, right? But we think in various different perspectives of the same context, right? It might act up differently, right? So I think you can understand even the tone matters, right? Ki, hai, if I say "huh," right, I'm surprised, right? So if I take, I mean, make the tone in a different manner, right? You'll say, oh, okay, I'm having different behaviors which are associated with each of the words, right? If I talk about, right, and that conceptually makes the things different. Is it clear for everyone? Understood, right? So the whole idea is the human's thinking is non-linear, right? And based on context. Why am I saying the word context? It is because, right, the meaning of the word I can decipher. I think you can understand. If I give you a big passage, right, you read the passage, okay, then can you tell me in a very short span of words, right, what this passage is all about, right? Obviously, right, you can easily say that, okay, this passage is all about this X thing, right? Meaning my understanding or anyone else's, all of us's, our understanding is bit more into what context I'm getting from neighbors, right? कि तू क्या बता रहा है भाई, तू क्या बता रहा है भाई. So basically it's from the neighbors, right? What do you have to offer, right? So in the context, in that same, right? And overall, we make the perspective, okay, this entire thing is about this, right? So if I talk, right? So we don't process words in isolation. That is a very important term. Isolation, simply, everyone knows what is the meaning of isolation, right? I mean, separate, right? If I talk about, right? We don't talk about words in separate, right? That's how you talk about banknotes or river bank, right? If I talk about, right? So that's train meaning training, or train meaning the physical train which travels on rail, right? If I talk about, right? So if I talk about in the context, right? So that's the surrounding. What I mean to say is the surrounding context, meaning Saomya trains the trainers, right? Or trainers trains Saomya, right? If I talk about, right, in that context, trainers and train are what is making train, that object train, as a adjective rather than as a noun, right? The representation differ, right? If I talk about, right? So I think more or less you understand attention mechanism, right? Word weighs each other based on relevance, focus on important connections which it has to offer, right? If I talk about, right? Now, multiple perspective, I think more or less you are understanding this context, right? Who is speaking, right? Focuses on the speaker who is trying to speak, right? What is getting captured, right? Meaning of, I mean, semantic meaning, right? In fact, not just semantic meaning, what does it imply? Meaning the hidden motive behind saying all of this. So he has said all of this. What does he want to say, right? If I talk about what is being implied, right? So if I ask you a question, if you keep quiet, right, I think that I am like, okay, I'm a joker who is speaking like something, right? So in the context of that, right? When I say, do you know about this? So you understand, okay, I'm taking an example of, okay, I'm referencing a question. I'm talking about a question, and you understand back and you answer. So I think of in that manner, right? So what is being implied also has implications, right? So then analyzes the grammatical sequence of relations, if I talk about, right? So attention, a very subtle way of what do you say, summarizing it all is attention allows the machines to process language, right, in the way humans do, that is contextually and selectively. Meaning sometimes, right? Uh, like this happens whenever someone asks for break, right? So we selectively hear, right? So we would put some more emphasis on the word break the moment I use the word break, after a very long hour of session, right? Rather than giving weightage to what is being said, right? So kya hi bakara, then you come up with a somewhat in the conversation I use the word break, then all of a sudden you give attention to that, right? So that's exactly what is happening here. So when and where to put focus and on which word is what is happening behind the scene, right? So contextually, and that is why I'm using the word selectively as well, right? Depending on the context, you activate something or you do something, right? Each head learns different perspective, and I think everyone understands that a collective intelligence is always better than single perspective. The best example is working in teams, right? What is beneficial working with teams, guys? What is so benefit? I could have worked like any person can work individually, right? So what is so benefit? What is the benefit of a team?
Collaboration.
या एग्जैक्टली बता भाई तेरा क्या पॉइंट ऑफ व्यू है मेरा क्या पॉइंट ऑफ व्यू है थर्ड पर्सन फोर्थ पर्सन कोलैबोरेटिव intelligence. So I should say, like, that's what we talk about, right? The collaborative intelligence is way more better than a single man's perspective, right? If I talk about, right? So I hope that's understandable by everyone, right? So moving forward, if I talk about, right? So let's say, what is attention doing really, if I talk about, right? The whole idea, right? The whole mechanism is nothing but a giant big matrix, guys. Okay. It is all about, it boils down to matrix operations. Okay. We'll look into it, better perspective. Okay. Now, for now, right, you can see the core idea behind attention, right? It says weighted aggregation of the context. And what is the meaning of context? In fact, the meaning of word context is meaning. Okay, so I mean, yeah, that's counterintuitive, right? Context or meaning, right? What meaning it has to offer, right? In the context there, right? So it is nothing but, and you can see the word called weighted, right? So you might have a vague idea of summation, somewhere, right? In the vague idea, okay, I do some XYZ operation. At the end of the day, I have to sum it all up because I need to think about it in different perspectives. And perspective one, okay, you have this. Perspective two, you have this. Perspective three, you have this. Perspective four, you have this. All you do is take a sum total of the perspectives and then you make your final perspective into account. You keep the final perspective into account, right? I hope that's particularly understandable in the context here, right? In a very relative term, right? So you can see here the context vector. Guys, look at this. There are two words here, okay? You have something called as a token vector, and now you have something called as a context vector. Both of them words have the same word called vector, right? But, right, what is so special about the context which is not there in token? What do you think, guys? Quickly, any thoughts about? There are two words here, context vector or CV in the context here, right? If I talk about, and token vector. So what is token vector, by the way? What do you understand by the word token vector?
Word embedding?
Exactly, right? Token means that word, I mean, very simple layman's term. Let's say a token is equal to a word, but that is not in many of the scenarios. But for our convenience, the word 8 is, let's say, a token, right? I'm representing it in 12K dimension. Okay, that becomes the total, becomes the token vector, right? If I talk about in the context there, right? So I hope it's particularly understandable, right? But however, it is not completely a token vector because token vector also has a little bit about the position as well. So what you provide, position plus this, right, gives you an output as a token vector, right? If I talk about in the context there, right? Now, obviously it has some meaning, okay? What is the meaning? It has the positional meaning, right? But you should understand one thing, that can I say that just because I have the position meaning, right? Can I say it also understands from the meaning from different other words? Can I say that? Is it positional meaning same as what do you say? Having meaning from all the other words? What is it all about? Is it same? Anybody? Did we all understand the question here, by the way? Is the token's final meaning equivalent to what you say, just like how we discussed about having the idea of, okay, यार ये वाला जो word है ये इसके वजह से आ रहा है, to complete context. So is it like that, by the way? Yes, no, maybe.
सर एक बार थोड़ा क्वेश्चन एक बार रिपीट कर देना सर.
Okay, yeah, yes sir. Yeah, right, sir. So my question is, हमारे पास, let me maybe draw it all for us here. तो मेरे पास, मैंने जो अभी बताया, राइट, मेरे पास वेक्टर्स है, राइट. तो एक है वर्ड एम्बेडिंग वाला वेक्टर, राइट. मैंने इसको ऐड कर दिया पोजीशन एम्बेडिंग वाले वेक्टर के साथ, राइट. दोनों को ऐड करके मेरे पास आ गया फाइनल इनपुट वेक्टर, और आई कैन से token vector, right? Whatever, I'm just giving it in a vague sense, okay? तो अब मेरे पास ये आ गया, right? ठीक है. ये अब what I'm asking you is, right, कि ये जो टोकन वेक्टर है इसके पास पोजीशन वाला इंफॉर्मेशन तो है, राइट? इसके पास वर्ड का भी इंफॉर्मेशन है, राइट? बट डज दैट मीन दैट सपोज मेरे पास एक पैसेज है, राइट? उसमें जनरेट, लेट मी डू दिस एक एग्जांपल के तौर पे, यार आसान करने के लिए ना, मैं एक एग्जांपल ले लेता हूं आप सभी को. भाई चैट जीपीटी से ही पूछते हैं तू कैसा कर रहा है. चलो
सर कैट वाला एग्जांपल.
You mean something like semantic meaning?
हाँ, exactly. So I mean, just what I want to talk about is, let's say, give me a passage for trains. Oh, let me do that. Okay, so I have this. Okay. Okay, anyways, आप यहाँ पर देख रहे हो, there is a particular passage, okay? अब ये बहुत बड़ा है, right? You saw me taking 4-word example, 5-word example. This is a relatively bigger example, right? If I talk about, right? अब मेरे पास पहली बात तो the कहाँ पर exist कर रहा है, उसका वेक्टर है मेरे पास, और the का embedding क्या है, वो भी है मेरे पास, ठीक है? If I talk about, right? Now, what I want to ask you here is ये जो पूरा पैसेज है, तो मेरे पास अभी आई थिंक अगर मेरे पास लेट्स से नंबर ऑफ वर्ड्स, लेट मी टेक दिस, ओके, whatever. Yeah, so you can see I have the passage is of almost near to 120 words, ठीक है? जो passage हमने यहाँ से लिया है 120 words, right? और each of the word, because I'm talking about chat GPT, let's for convenience we talk about GPT-3, right? तो इसमें जो इसने बनाया है, so it is a vector represented in 120 into that 12,288 dimensions, right? So उतना बड़ा हमारे पास एक वेक्टर है, ठीक है? So if I talk about, right, what I wanted to ask you in this question here, right, कि क्या जो हमारे पास जो टोकन वेक्टर है, right, टोकन वेक्टर is for single words, right, if I talk about, right, and which we just saw it here, right? Now, does this token vector have any understanding of what this passage is all about? Can the token vector talk about it individually? Can each of the token vector talk about what is this passage all about in the initial stages? Can you tell me about that? ये था मेरा original question.
No, I think it doesn't have any information about the entire passage, right?
Yes,
it doesn't have anything.
Exactly, there, sir. Exactly. Perfect. This is exactly what I.
Each word doesn't have that idea about the other word.
Exactly. Exactly, sir. Unless and until it interacts somehow, right, with each other, if I talk about, right. So I'm taking this as an input, okay, and then I'm asking the question that what is this passage all about, right? Let me ask the reverse question, okay. So what is this passage all about? Okay, so if I talk about and I put this, right, I just reverse the question, okay. अरे भाई नहीं बेटा नहीं चाहिए, इतना नहीं चाहिए मुझे. In few words, I think I'll probably so you can see, right, the passage describes the atmosphere of a train station and journey using the train as a metaphor for life transitions, right, blending routine with a sense of possibility and the unknown. The thing which it has generated, guys, right, what I want to ask you is, does it have an understanding of it for now? What do you think? That was my question, original intention of the question which I wanted to ask you, right? So it only has specific information of the individual word which you are feeding as input, right? But it does not still have any idea about what the collective thing looks like. Is it understandable? Yes or no? Right? Understandable? समझ में आ रहा है सभी को? Okay, perfect, sir. Perfect. Thank you so much. Awesome. So now that we understand that, this is the exact difference. So you can see there is a term, right? If I talk about the weighted sum, if I talk about, right, which is again given to the token vector to make it contextually rich. Okay. To make it contextually rich, meaning contextually meaning what is the meaning of the passage, right? You have individual tokens, you pass through it, right? And then somehow you do some kind of operation in that giant head of yours, right? And get something called as a context vector, meaning things which can talk about what is it all about. Do you get it? Is it understandable to all of us, right? So you're doing some kind of operation to get that. Yes or no, right? Got it? Easy to understand this now a little bit. Perfect. Thanks so much, Raja sir. Okay, so I think more or less we understand that, right? So let's look into a few things more, right? Attention mechanism internally, what is happening? If I talk about, you can see here, right? So you listen to all, right? Meaning every word, you saw 118 words in that passage earlier, right? You listen to all of those words, okay? Filters out information, right? So assign relevant scores to each of the token, right? Because each and every token, how would it even know that what to give out, right? It is because each and every token has to, I must say, has to have some say to the overall output. Okay, we'll look into it more. Weighted importance, if I talk about, you create weighted representation of the context. And if I talk about integrates knowledge, which is basically nothing but builds contextual understanding. Okay, so let's look at it, okay, one by one and talk about that, right? You can see here, right, the dog ate food quick, right? Or whatever. If there was a sentence having the dog ate the food quickly, whatever, right? If I talk about, right? So in the context here, right? If you look into, right, the you can see the weight. Like, this is a hypothetical scenario, doesn't have to be exactly like that. So the idea is you want to put more weightage to the noun in this context, right? These are the nouns in the, because these are the doers, right? If you talk about, right, the dog is the doer, or food is what he is eating, or if I talk about, right, in the context there, right? And you can see that who I mean, you ask the particular question saying that who ate what, if I talk about, right, in the context here, right, referring to that, right? On the relative context, if you see this, right, I mean, these are random values, by the way. It should have been it should also have given some priority to quick as well, because quick eating is it's like a adjective, right? If you talk about, you can eat the food slowly, you can eat it quickly, right? If I talk about, right? So if I ask the question, how did the dog eat the food, you will say that the dog ate the food quickly, right? If I talk about, right? So quick also makes some sense if I talk about, right? But in the context here, right? But however, the contribution of the, because the language has a relative, I mean, if I talk about, doesn't add meaning or context to the overall output, right? Obviously, using the word the, right? You can't, can you guys figure out if I say that what is in my mind, what am I thinking? If I give you the guess word as the, can you tell me what am I thinking, guys? Oh, so I just give you the guess word as the. Can you tell me what am I thinking?
No.
Obviously, right, sir? Exactly. Just like you talk
I
about,
guess
right?
we need to cannot some specific like unique things, and maybe
Exactly.
we might have came across before to uh, that thing. Then we can mention. Yes.
Exactly. I mean, no, yeah, exactly. You're right, sir. Meaning you are saying that if I had given some passage about, I have given some hints, and then because the doesn't make sense as a hint as well, right? So if I talk about, because I say that I thought of a five word sentence, right? And there is the in the sentence, right? Obviously, there can, I mean, the world is full of the, I mean, in the contextual terms, right? Oh, if I say the word right? If I talk about, right, you can't make out in the context that what am I even referring to, right? But on the other hand, if I say maybe I use the word elephant, right? It makes it more realistic. Okay, meaning you now would be thinking maybe in the context of, okay, then I can move forward, right? I can ask, is the elephant running, or is the elephant what do you say? I don't know, it trumps, right? So is the elephant trumping or making sound, or maybe is the elephant, are you referring to the color of elephant, right? That is gray or whatever, right? If I talk about, right? So these words contribute to some kind of a contextual meaning to the entire sequence, right? And that is learned over time, right? If I talk about in the context there, right? So look into it, right? Just in a vivid picture, right? If I talk about, right, you can see that that's why relatively the word dog and the word food have relative higher preferences compared to the word the and quick. Maybe in the context of quick, you can even say that what is quick? I mean, on what reference are you talking about quick, right? Is it for food? There can be hundreds of different choices, right? So running quickly or eating quickly or maybe XYZ thing, right? That's why I think you can understand that even quick has, but the relative importance of quick should be better than that of the in the context, because quick is relatively more inclined towards giving you some aspect compared to the, because there the is the, what do you say, a regular representation of the English language, right? So I hope it's particularly understandable. Is this point clear to everyone? Can I get some thumbs ups and stuff? Is it all clear to all of us? Perfect, perfect. Thank you so much, sir. हाँ, बीच बीच में थोड़ा सा पूछ लेता हूँ. So, all right, brilliant. So next, moving forward, let me go to the next. Okay. Now, here's the thing, guys. Okay. Here's the interesting part. What happens? Okay. So all the things which you talk about, right, in the attention mechanism, right, if I talk about, right, is divided into three things, three distinct things. Okay. Query, key, and a value. Okay. So these three are individually, they are matrices to be thought of. Okay. So you can see here, right, there is a input vector, right? You have a query vector, right? If I talk about, right, you have a key vector and there is also a value vector, right? Okay. So let's look into it, okay, in a more intuitive sense, so that you can get a understanding of it, right? So you have this, right? So in the context, you can see here, right? Each word vector is transformed by learnable matrices. Okay, you can see the word learnable matrices. So many of you can call these learnable matrices as individual hyperparameters. Everyone remembers the word hyperparameters, right? Tunable parameters. Is it clear to everyone? Yes, no, maybe. All of us in deep learning have been through these words a couple of times, if I talk about, right? Is it understandable? Yes, no, maybe?
Yes, yes.
Yes.
Perfect, perfect. So they are learnable matrices. I think you can understand. I think even Ankit Paji, he in the previous sessions of RNNs, right? He had showed us how those parameters learn as well, right? Because those parameters change over time in order to give you a certain output, right? In the context there, right? If I talk about in the relative aspect, right? So you repeat it several number of times. So that's why you use the word learnable matrices, right? Or things that can be tuned up, right? They are like tuning knobs, right? If you talk about the volume up and volume down buttons, which you have on speaker, right? Same way, you have the learnable matrices, which talk about in the context there, right? So these matrices denoted mathematically as WQ, okay, for query matrix, right? WK, and I'm talking about W means weight, right? Weighted, I mean weights, query weighted matrix. If I talk about, right, key weighted matrix, if I talk about, and the value weighted matrix, right, which project the input into query, key, and value spaces. Okay, enabling the attention mechanism to compare and weigh the tokens. Okay, so in the context there, if you talk about, right, these are the ones who actually, wo jo tarazu hota hai, these matrices help you to shift those values up and down to a particular question. Okay, so let's quickly talk about it, right? So these matrices are trained during the model optimization process, right? Obviously, if you talk about in the context, right? So which gets trained up, right? Because of the context which we are talking about here, right? So allowing the network to learn how best to attend to a relevant information, right? So I think more or less it makes things clear to understand, right? So because these are tunable parameters over the course of the time, right? If I talk about, right? So it gets to learn a lot of things depending on the world knowledge it has collected over time, right? So, and I mean, each head transforms the same input into different QKV vectors, okay? QKV vectors, allowing diverse perspective on the same set of information. Okay, so we'll talk about it. Okay, diverse perspective. Why am I saying diverse perspective? This is for a further slide. Okay, we'll talk about it. Okay, that is what is referred to as multi-headed attention. Okay, we'll talk about it. But as of now, single head attention simply means you have a query matrix, you have a key matrix, and you have a value matrix. Through over the course of the entire series, it makes changes to the original input to give you the course output, right? So in the context here, you can see here, right? So I have the query, right? If I talk about, you see the query matrix, right? Okay. And by the way, what is the word query refers to, by the way, guys? What is the meaning of the word query? What can you understand by the word query?
Something like a question?
Yes, exactly. You're right about it. So it is exactly, obviously, you can't demonstrate it. What is the exact question which is asking, because the numbers are encoded in the form here, right? But it is like, if I talk about, right, let me give you a subtle example to elaborate this fact to all of you. Okay, so I have, you know, right? Do you know the sentence which contain in the English language, which contains all the letters from the English alphabet? There is a sentence which contains all the letters or alphabets, I should say, in the English alphabet.
Kind of remember, but I'm not exact what it is.
Exactly. I'm just giving an example.
The sentence start from the fox,
The
something
lazy,
like that. I'm not
yeah,
able
the
to
lazy
remember
fox.
that all words.
Lazy fox jump on something.
Yeah, exactly, sir. Yeah. A quick, I should write it. Brown fox
Jump into something will come. I don't know exactly.
Right. Exactly.
Some dog it is, something.
Exactly, sir. You're right. Jumps over a lazy dog.
Yeah.
Yeah. Perfect. Thanks for all the efforts, guys. Yeah, exactly. This one contains all the alphabets of the English language, obviously with a loud repetition, right? You can see A repeating, but you can see that XYZ is also there, right? If you talk about, contains all the letters in the English alphabet, right? Now, this somehow seemed very familiar to me because there are few things. So in this, what is the noun here? Can you all identify the noun here?
We have a fox and a dog.
Perfect, brilliant, awesome, nicely
Dog is
said.
also there.
Sorry, sir. Yeah, dog also. Yeah, exactly.
Fox, dog.
Yeah, exactly. Right. Brilliantly said, sir. And what are the adjectives here?
Lazy, brown.
Quick,
Exactly.
brown, lazy.
Quick,
exactly.
brown, lazy, like that.
Brilliantly said, sir. Exactly.
Not
So,
sure. These also, whether these adjective?
Yeah. Which one, sir?
Whether the first one, these adjective? Is it adjective or?
No, sir. No, that won't be considered in the category. Adjective is something which describes the noun.
Describes,
right?
yeah. It describes.
Yeah. So the fox is a noun. So what kind of fox is it? What color of fox is it? Brown, right? So and basically, how is the fox moving? Maybe a quick fox, right? If a brown fox, right? You got it, right? So both the words describing the word fox.
No, it's out of context. You might scold me.
No,
H is
sir.
not
That's
found out
fine.
in this sentence.
Sorry, sir.
H is not there in this sentence.
HT. Yeah. So I think, sir, that is not I believe. You're right about it. I think it will be the, right? Because I don't see H, right? My mistake.
Yeah.
Thanks, sir. Yeah, thank you so much for correcting the perspective. Yes. So it is actually
Don't scold
the.
me.
No, sir. That, nicely said. So that's good, sir. Yeah, I'm happy that made the observation. That's really good, sir. Yeah, exactly. So you have the quick brown fox jumps over a lazy dog, right? Perfect. Thanks for sir's correction here. So it is the actually because H was not part of it, so it should be the over. Or actually, it should have been like this. As per the English placement, I believe it should be over the lazy fox. I'm not sure. Yeah, I mean, more or less, a quick brown fox jumps over the lazy dog or whatever, right? So if I talk about, so, but just like how correctly pointed out by all of us, all of our fellow friends here, right? Yeah, ले लिया मैंने. चलो. So you can see that the word fox, which is a noun, that is getting what do you say? It is affected by what color of the fox it is, right? It is a brown color fox, right? And also, right, it should have focus on the quick adjective as well, right? Because the quick meaning, what do you say? It shows that the brown fox is quick enough to jump over, right? I hope that's particularly understandable, right? So two adjectives describing the noun here, right? And how is the dog here? The dog is lazy, right? If I talk about, right? So I think you can now understand. You earlier, I think I think Aditya sir earlier said, I asked you the meaning of query. You said the word query means question, right? Okay. So basically, each of these words, okay, go through something called as a query vector first. Okay. Now, when I say query vector, obviously, if I ask the question, right? If I talk about, right? So as there is no question, like suppose I'm one of the, I told you, right? It is thinking in different dimensions. Let's say one of the dimension is adjective. Okay. Let's say one of the dimension is adjectives. Okay. So it asks the question, right? To suppose, obviously, is I mean, is A an adjective, right? If I talk about no, obviously A is not an adjective, right? It asks the question, is quick an adjective? Yes. The quick. So for that adjective matrix, right? For that adjective matrix, quick will have more importance. Do you get it, right? If I talk about that adjective perspective, right, quick will have a more, what do you say, perspective than the letter A, right? If I talk about, right. Similarly, the word brown can be a noun as well, right? If I talk about, right. So in that context, so it can both go into noun as well as an adjective, right? So brown has to interact with its surrounding to understand whether brown should be taken as a noun or a adjective. Is it clear to everyone? Am I able to make things clear a little bit in the perspective of how the questions are being asked here, right? So now, perfect. So same way goes for the fox, right? So the initial question you might ask is it a noun or is it a adjective or something in those lines? So a set of questions that is nothing but encoded in the form of numbers, right? So suppose this question says, is it adjective? Okay. Similarly, there will be a set of vectors which will say, is it a noun? Okay. There will be a set of vectors which will say, is it a pronoun? Okay. So X, Y, Z thing, a lot of different things if I talk about, right? So, but they will be a set of values, right? They are all in the set of values, right? Now, in the context here, if you talk about, if you see the fox here, right? So the whole idea here is, right? Now, the query, one of the queries is, right? If I talk about, right? What is it itself, right? If I talk about in the context, right? The other, which can be focus on my question here. Okay, I'm at fox, right? I ask the question, is there an adjective near me? Okay, I ask the question, is there an adjective for what? For the word fox, I am asking the question in the form of matrix, obviously, just like how you saw earlier, right? In the form of matrix, I'm asking a logical question. Is there an adjective near me? Right? Is there an adjective near me? Okay. So I think you can understand that is why these all set of questions you write. So imagine this as a giant set of matrix containing individual questions. Okay. And these individual, it's not a single question which it asks, by the way, it is a vector of questions. So that is why it is not just a single vector, right? By the way, if I'm representing it in top down format, it will be a longer bit. So this will be question 1. There is another question 2, there is question 3, right? There are question 4, right? Generally, as per what they have taken, the number of questions is actually similar to the number of dimensions. Okay, so to do the matrix operation very easily, it was chosen that the number of question in each set of query matrix, right? So this entire thing, this entire set of values is what you call as the query vector, right? Or I'll probably use this term here, right? Weight, what do you say? Weight matrix for the queries, right? If I talk about, right? Is it understandable to everyone? Are we understanding? So there is question. There are various questions which it tries to ask for each of the words present in the context. Yeah, sir, you have unmuted. Yeah, yes, sir. Others, sir.
So the weight query will be same for every word?
Yes. Nice question, answer. Yeah. For the word A, it goes through the exact same query. Okay. So it has a set of questions, and for that it get a representation. For the word quick, again, it goes through the entire set of queries. For the word brown, it again goes for this entire set of queries. For the word fox, it goes through the entire set of queries. The word jump, it goes through the entire set of queries, and so forth. So when you write a big passage, it is actually going through each and every word is going through the entire set of matrix. I mean, the entire matrix to speak of. Was that your question, sir?
Correct me if my understanding is right.
Right. Yes,
so what you meant is like every word in the context, and every word will be every word has an embedding. With number of dimensions is there, it will have an embedding. So this embedding will will have a dot product with this weight matrix of the query, which weight matrix of query is a weight of query is something like a constant for every embedding, right? Weight query is constant, or is it changing?
So weight query, nice question, answer. When you talk about the weight query, right, these all initially get so when you talk about the transformers, right, there are two phases, right? One is pre-train, I mean, during the time of training, right? While you are training, those are randomized. But what you get as the output of the training is these weights are very specific. You got it right, sir? Meaning they are no more randomized, because now you use these weights to now they deploy it on the system, which now we type the question as what. Suppose my question is what is the current year, right? To Chat GPT, right? Now it that same weight embed. It gets embedded, right? And then each of the query matrix, right? When during the time of the starting, it has a fixed set of values through which it goes through. You got it right, sir? So meaning there are two perspectives. During training, it is randomized, but after training, when you get the final model created, right? You have those those vectors as fixed set of numbers which go through under each iteration. You got it, sir?
So weights are like hyperparameters which get trained, especially we are changing the embeddings of weight query. And finally, after learning, it has a constant, this one, and that query, that vector is multiplied by each embedding of that sentence, right?
And
the sentence has each word.
Said, sir. Exactly. And to add up here,
yes, I just want to add something here. Not others, like not from the initial point, okay? From the initial point, your weight is like never. It's not going to be like we are going to distribute it from now. it is completely on Adam only. So if you are using Adam optimizer, it will definitely do it. The initial your weight optimizer, like if you are inputting the weight, dimensions are going to be same. Whatever your query key or the value dimensions are there, same dimensions, weight will be there, and it is going to be identity matrix only. Initially.
Perfect. Initially. Exactly.
Initially, and after that it will get learned, and then it changes
over a bit.
Query changes.
Yeah.
Right. Exactly. Because sir, that is where the tuning comes. Nicely said by sir. Because sir, because now understand this, sir. You say that's why, sir. You ask the GPT to become like an actor, right? So to enact something in that field, like for example, you want the clarification on a medical term, right? So there is one perspective where you talk about layman's language, right? Now you change the perspective, saying that I want it as a what do you say? A real doctor, how a doctor would talk about it, right? So there you visualize it differently, right? So the set of matrices again undergo change, but initially it starts with the same set of parameters, then undergoes with the refinement which you, which even Adarsh sir has just described about. Got it? But we should also understand that whatever we see in the GPT, that is out. I mean, as a what do you say, post training phase, like when you are realizing this stuff, right? When you are using, because there is a model already created. That model again in the context of the understanding gets trained. But initial level, the words are fixed in the context. They get learned according to the context again. Meaning not learned, meaning they change their form again based on the context. Got it, sir?
Yeah, one more doubt. Doubt is here the 0.15, 0.22, and 0.808. Is it the weight of the query matrix, or after your multi dot product with the embedding?
Sir, this is the weight of the query matrix. Okay.
Weight of the query matrix.
Meaning,
0.15, 0.22.
Exactly. What you see here, WQ, right, is the weight of the query matrix. That's what we are referring to.
Now, this weight of the query matrix is we do a dot product with the embeddings.
Exactly.
So
we do the dot product.
So we find the query of A, then query of quick, and query of
exactly. Brown. Exactly. And so forth, right? So if you talk about, because I think you can, this is how we as humans also think, right? That when I say quick brown fox, where do we put emphasis on? He said the word brown for the word fox, right? If I talk about, right? So I'm emphasizing that the color of the fox is brown, right? So that's exactly what Transformers is trying to mimic as well. Got it, right?
Yes. So finally, after the query that query matrix of A, it will be the dimension of weight matrix, or whether it will be dimension of the embedding of the matrix. Just one confusion. Like, what will be the output of QA?
Let me talk about that as well, sir. Right?
It will be a series. It will be a series for that one query.
So yeah, exactly. Sir, just like how sir elaborated it here, right? Let's take this. By the way, a fun fact here: the query matrix, key matrices, generally they are taken in a lower dimension. Okay, lower dimension. Okay, let me tell you what I mean by that. Okay, we are getting into more technical stuff, but let me just quickly iterate it. Okay, so I told you that GPT-3, let's talk about GPT-3 numbers. Okay, we started off the initial embedding size, if I talk about 12 to 88, right? If I talk about, right, the query matrix, especially in GPT-3 numbers, is a matrix of 128 dimension. You see, the number 128 is way more smaller than 12K number, right? Got it? Everyone understood? I think others, sir, is it understandable? So it is.
Yes.
Yeah. So I say question 1, whatever the question is, that exists in I mean, let's say small q1, q2, q3, and so till q128. Okay, I represent it in the format. Okay, got it. So similarly, question number 2, I have it here. Q2, I don't know. I mean,
No, it will be the same, right?
yeah,
After after the
one,
weight
yeah,
matrix of light, it will be same.
exactly. So Q21, Q22, Q23, I just have that, and Q2 2 of 128. You got it, right? So I have, but I said that the number of questions which you ask, okay? So it is, this one is a single question, okay? Suppose this question says, is it a noun? Okay, I'm asking the question as, is it a noun, right? N-O-U-N or W-N, I'm not sure. But is it an adjective? The second question is this an adjective? Okay, I'm giving a hypothetical scenario that's nothing to do with noun adjective. It's so I'm asking third question as, is this a color, right? Suppose, okay. Fourth question as, is it male or female, or maybe is it a male? Okay, I'm just inventing questions. Okay, so all of these are existing in 128 dimensions. Okay, so 128, right? And how many? If you saw me having rows, right? These are rows, right? How many columns are we having? The number of columns is 12k. Exactly. I mean, similar to what we have it here. Why are we having it here? Because the reason, so there are, so how many, I think you can understand what is that signifying? That means I'm asking question 12k, meaning there are 12k questions I'm asking in that particular big matrix. Okay. And what am I doing here? When I do the dot product of what I'm having, this one itself is 12k, right? In the relevant context, right? So you get wind up and 12k of 1, right? So you had initially 128, 12k, and this, right? So it boils down to one single stuff. You got it, right, sir?
Yes, kind of. Little confused.
So वही मैं बता रहा हूँ कि there are 128 rows having specific numbers. Okay, these are different questions which so this entire, by the way, this entire thing, I think you got confused because of this. This entire thing is, if you talk about, right, what acts as a complete query vector, WQ. Do you get it? This entire thing. So if you talk about the complexity, it is having 128 rows and 12 to 88 columns, right? So that is the query size of the matrix which I'm talking about here. Okay. And if I talk about this input is a single dimensional stuff which you have put in, right? If I talk about, right? So that's what you are talking about. So I think you can understand, right? It is safe to say 12k, right? Comma 1, if I talk about, right? And if I do the operation, you end up having 128 comma 1. That means one vector representing having what you say 128 words. Did you get it, sir? Now is it understandable? You do a multiplication between these two, right? Don't you, sir? Let me do this. You have a 2 cross 3 matrix, right? You do this, right? And 3 cross 1, you wind up having 2 cross 1, right?
2 cross
Isn't
1.
it correct? Yeah, right? Exactly. Yes. So you have a big chunk of this. You pass it through, because this one is already having that dimension, right? You have that word embedding dimension, embedding plus position, right? That dimension you already have it, right? And you do the operation, and you wind up getting 128 cross 1, right? You got it, right, sir? Okay. So it goes through a series of numbers, right? And each of the number focusing on different set of questions. And this is just a single unit, by the way. Okay, this is just a single unit. Okay, so I hope you can understand the context. समझ में आ गया सर? ये थोड़ा सा critical है, but this is how it works out.
So finally we'll have 128 rows and
Cross
1 column.
1. Yes, sir. For GPT-3, not for everyone, for GPT-3 model. You're right. Got it, right?
Okay. Yes,
and these are all hyperparameters. I think you can understand each of them is a hyperparameter, right? Because I told you, initially the words are fixed, right? Initially these numbers will be fixed, but as and when the context it gains context. It keeps on changing in the context of thoda relative changes aane lagenge, because just like how sir quickly described it as, right, jo wo distribute hoga, because you are encountering error, the loss function gets what do you say, distributed across. You got it, right, sir? So थोड़ा ट्यून नॉब ट्यून होता रहे. समझ में आ गया सर? Is it understandable? थोड़ा सर कॉन्सेप्चुअली है सर, इसको थोड़ा समय लगता है डाइजेस्ट करने में, बट द ओवरऑल आइडिया इज द सेम. गॉट इट सर?
Yes sir, yes.
Nice, brilliant.
Soumya sir,
sir बताइए.
The main thing is like, until and unless you go and read the research paper, there is any alternative for that. So there is no other option for learning the transformer. There is no.
सर मैं हमेशा सोचता हूँ सर खत्म करवा दे फिर, बट सर आई एम वेरी हैप्पी सर आपने ये सारे क्वेश्चंस उठाया सर, एंड इट्स रियली an in-depth intuition. And I think Aditya sir, you see, right, how the perception changes. Aditya sir, two brains acting here, so you can understand the two different angles and the way you get the output, sir. So actually it works in a very similar fashion in the context. Sir, Adarsh sir, you have something?
No, the thing is, I did read the article, but I forgot many things, and somewhere I'm confused with the matrix which has been formed. So what I had a pre-knowledge is that that you see, even you make sense of what you said, and what my pre-knowledge is that the query of every word is there, no? So there are you have different words, and every word has their embeddings. Every word, like for example, the GPT-3 model, your embedding of each word is the dimensions, which is 12K.
12K, right, sir?
12K dimensions. So the query vector of D will have the final output as 12K, right? It will be 12K, 12K columns will be there.
No, sir. Actually, that's the whole point of here, sir. Right. So here's the thing, sir. You are actually dividing into subsections. So you have close to around 28,000 matrices in the entire space. Okay. So each of them is contextually. So sir, it goes through a series of because sir, yeah. Sir, as of now, I'm just, by the way, you are right about one thing. I think, sir, we are getting confused a little bit. आप जो बता रहे हैं ना सर, ये जो query, हाँ, I think now I understand what the confusion is. Sir, ये जो query है ना, the query space exists in 128, okay, sir? But you are right about one thing. You need 12K. That is right. But this will happen gradually. I haven't discussed about key and value, especially value. ये जो आप 12K वाला जो concept आ रहा है ना सर, that is happening in the value. You got it, sir? वो upscale हो रहा है. यहाँ पर ये दोनों में ये सर down matrices बन रहे हैं. ठीक है सर? मतलब आप उसको और concise way में आप उसको basically एक बड़ा zoom level है, आप उसको छोटा करके इसमें आपने देखा, राइट, एंड देन यू आर अगेन मेकिंग इट एनलार्ज्ड इन दैट स्पेस, क्योंकि आप 12K डायमेंशन में ही काम कर पाएंगे. डिड यू गेट इट सर? अंडरस्टूड, राइट? सो अब सर आएंगे, सर उसमें आएंगे, राइट? सो लिटिल बिट, राइट? सो थोड़ा सा, बट यू आर राइट अबाउट इट. द क्वेरी मैट्रिक्स, द आउटपुट इज अ वेरी रिलेटिवली स्मॉलर डायमेंशन. ठीक है सर, राइट? गॉट इट? अंडरस्टूड सर?
I think I will also just go and revise once.
हाँ,
somewhere
एक बार आप
वही बेस्ट हो जाएगा.
हाँ, मैं अभी सर आगे सर वैल्यू के ऊपर बात करूंगा ना सर, आपको पता चल जाएगा मैं क्या बोल रहा हूँ. ठीक है सर? तो यू विल गेट द अंडरस्टैंडिंग. अभी के लिए हमने उसको छोटा कर दिया 128. ओके सर? सो एज ऑफ नाउ वी हैव अ वेक्टर व्हिच इज हैविंग 128 what do you say, dimensions, right? Ankit sir, you had a question or something, sir? I'm sorry.
I just want to say to others, whatever article you are referring is actually like the article is correct. They are talking about the whole vector, like including the query vector of each and every word. Okay, so then they are talking as a whole. Here, they are discussing for one word. One word, how one word is connected with all these words. Like
Right.
that
And
word is asking that how I'm related to you, how I'm related to you,
Exactly.
like
Exactly.
that.
others, instead of considering that 12,000 dimensions, you should start thinking with only 4 or 5
Four,
dimensions
हाँ,
only.
four. सही रहेगा
Those
सर.
are best, not
हाँ,
even more than that.
exactly
Because
sir,
apart
exactly.
from that, it's gonna be very confusing.
हाँ,
Like if you just consider that you are having a query, okay, you have a query matrix, and let's say currently your query matrix is 3 into 3, okay, you are having 3 words, it is 3 into 3. Your query matrix, your key and your value is going to be 3 into 3, okay. Once you multiply one query with one matrix, you will get a series. You convert the key also, you transform the key similarly, you transform the value also similarly. You are going to get a series of value for those 3 dimension word only, okay, not 9 values won't be there. It will reduce to 3 only. One word will be there and second word will be a third word will be there. That is going to be the perfect value for that.
right.
Okay, so imagine imagine 4 dimensions. The word has 4 dimensions. If the sentence is something same sentence, the brown fox. What is
ठीक है
it?
सर,
The quick brown fox.
मैं एक काम करता हूँ आपके हिसाब से, मैं इधर लिख भी लेता हूँ, ठीक है सर. लेट्स से अ क्विक ब्राउन फॉक्स, राइट. जो भी है, ठीक है, हमारे पास ये 4 वर्ड है, एंड यू आर सेइंग दैट लेट्स टेक द 4 डायमेंशन, राइट सर. पहली बात तो ये, हाँ,
So
फर्स्ट एंड
imagine
फॉरमोस्ट सर, हाँ,
A has
so
a dimension of 1001.
हाँ, एग्जैक्टली, ठीक है, राइट. और आपका 0101, हाँ ठीक है सर, मैं ऐसे ही बना दे रहा हूँ, राइट. 1100 समथिंग इन दोज लाइंस, एंड लेट्स से 0011, ऐसे ही बना दे रहा हूँ सर, ठीक है. वी हैव दीज 4 डायमेंशंस, राइट सर, ठीक है.
So I have now this query matrix.
हाँ, फर्स्ट एंड फॉरमोस्ट इट इज, सी, क्योंकि हमारे पास डायमेंशंस काफी ज्यादा हैं, राइट सर, राइट. इफ इन माय जीपीटी एग्जांपल, राइट. अब हम क्या कर रहे हैं, मैं उसी को मिनिएचर जीपीटी बना रहा हूं, ठीक है. तो हम क्या कर रहे हैं, लेट्स अज्यूम, ठीक है सर, कि मैंने आपको बताया कि उसमें 12 के डायमेंशंस थे, एंड इट इज 128 क्वेरी का जो डायमेंशन था, राइट. तो मैं यू हैव टेकन अ वेरी लो डायमेंशन, बट स्टिल सर, इसको पिक्चराइज करने के लिए लेट्स से 2D में पिक्चराइज कर रहे हैं उसी तरीके से, ठीक है सर, राइट सर. आई हैव टेकन अ क्वेरी मैट्रिक्स ऑफ टू डायमेंशंस, राइट सर, ठीक है. अब 2 डायमेंशंस में लेट्स से 0.5, एक क्वेश्चन नंबर 1, मैंने आपको क्या बताया कि it will ask you the same number of questions as that of the dimensions, ठीक है सर, you got it. It will ask the same number. So there will be only possibility of 4 questions. Question 1, question 2, question 3, and question 4. Got it, sir? Right? And each of the question will be having 2 matrices each. You got it, right? 0.1, maybe 0.2, right? Let's say 0.3, let's say 0.05, or maybe 0.01 and 0.2, whatever. ठीक है सर, समझ में आ रहा है सर. अब मेरे पास ये आ गया, ठीक है. दिस इज 2 क्रॉस दिस इज 4, राइट. एंड आई एम फीडिंग दिस गाय हियर. बाय द वे, वी शुड नॉट फॉरगेट कि इसमें पोजिशनल एम्बेडिंग भी जाना चाहिए. सो सम मैट्रिक्स, बट मान लीजिए सर, ये जो आपका जो वेक्टर आया है, इट इज आफ्टर पोजिशन प्लस दिस, ठीक है. अंडरस्टूड सर, है ना सर?
यस.
समझ में आ रहा है, हाँ. तो मैं ये जो वेक्टर ले रहा हूं, so it will be 1 0 0 1. I think it is safe to understand that this is again, if I talk about 4 cross 1, if I talk about, right. अब हम matrix multiplication अगर करेंगे भी, right, you have 2 cross 4 matrix and a 4 cross 1 matrix which results into 2 cross 1 matrix. तो इसका जो output आएगा ना सर, फिर से if I talk about in the context, you'll have a 2-dimensional representation, right? So maybe I'll have, let's say, 1.6 and maybe 1.4. You got it, right, sir?
Yes. Got it.
तो ये है जो हमारे पास फिलहाल हो रहा है, ठीक है सर. ओके. अब बाय द वे, अब एक लॉजिकल चीज सभी के दिमाग में आ रहा होगा कि what is this query, sorry, query matrix तो मेरे पास आ गया. What is this key then, right? What is the meaning of key, by the way? Can you tell me what is the meaning of key, by the way, guys? Anybody? हम लोग कहीं पर OMR में हम लोग यूज करते हैं की, क्या बोलते हैं उसको हम?
Like not able to understand.
OMR
It's like an answer. Something like an answer you could say.
Yeah, answer key. Do you remember, sir? Right? अब जब भी ये देते हैं सर, मल्टीपल चॉइस क्वेश्चन देते हैं तो पीछे की तरफ क्या बोलते हैं, उसी क्वेश्चन का एक पीछे की तरफ आंसर होता है, right? That's what I'm talking about, right? So you have a question, set of questions. There is an answer at the back of the page, right? Question number 1, answer is B. Question number 2, answer is D or X, Y, Z thing, right? You got it, right? That is the key which we are talking about. Got it? So that is meaning, यहां आपने क्वेश्चन पूछा, is quick an adjective, ठीक है, उसका आंसर is in the key matrix. Do you get it? Is it understandable? So the question, one of the question which I have asked is it a noun? Sorry, let's talk about brown maybe, okay? So is it a noun? So obviously yes, it is a noun, right? तो उसमें उसका subsequent answer will be available in the key matrix. Is it understandable, by the way? Right? Got it? The subsequent answer is available in the key matrix. Okay? So जितने भी questions आप पूछ रहे हैं उसके subsequent answers will be there in the key matrix. Yes or no? Is it understandable? The key means the key to the question. Okay? So Fox एक question भी पूछ सकता है, right? The Fox is asking the question, let's say, कि is there could be one set of question. It is asking that, is there an adjective near me? Okay, then this brown answers to that question that yes, I am an adjective. Quick answers that yes, I am also an adjective which you can use. Do you get it? Are you understanding the concept here, guys? Right? So for the question, for the Fox question, that is there an adjective near me, the brown becomes an answer. Also, the quick also becomes an answer. Is it understandable to everyone? But I think you can understand A वाले का relatively less importance होगा. क्यों? क्योंकि A is not an adjective. After training so many examples, it comes out that, तो आप एक ऐसे इमेजिन करो, इन सभी का आउटपुट A का जो मैट्रिक्स का वैल्यू होगा somewhere maybe close to 0.1 हो सकता है और maybe 0.2 हो सकता है उसी चीज का आंसर के लिए. But whereas the quick one will maybe having 15 as the answer, plus 15, or maybe brown का जो और ज्यादा weightage होके it might show you plus 20. Do you get it, guys? The weightage of these two words will have significant impact compared to the word as A, D, and others, right? Sir, Ankit sir, you had a question.
Yeah. So it is like that, that for each word, like for Fox, and we are comparing, and then we are giving a weight matrix or a matrix that we can directly.
Right. Exactly. You're
W
right.
Q means like for a particular word, we are having WQ. For some particular other word, we'll have other WQ with the weights, and based on their relation, we'll provide the weights. So that's the thing.
Exactly, sir. तो आपने जो जैसे बताया WQ का जो भी डायमेंशन था, ये बड़े के लिए भी WQ 128 क्रॉस 12K था, सेम एग्जैक्ट 128 into 12K will be also for WK, क्योंकि हर क्वेश्चन के लिए एक आंसर है, हर क्वेश्चन के लिए एक आंसर है, right? Brilliantly said, sir. Exactly, right? Is it understandable by everyone? सबको समझ में आया? Is it easy to understand, guys? समझ में आ रहा है? नहीं? थोड़ा क्या हुआ, सब लोग उड़ गए क्या?
सर ओवर टाइम हो रहा है.
हाँ सर,
ओवर टाइम हो रहा है सर अभी.
अच्छा हाँ सर, ओवर टाइम ओटी हो गया सर, ओटी हो रहा है सर. थोड़ा सा और पढ़ा देता हूँ सर, ये बाकी उसके बाद देखेंगे क्या करना है. एंड गाइस, द वैल्यू मैट्रिक्स है ये, इसको विल डिस्कस अबाउट अ लिटिल बिट आफ्टरवर्ड्स, ठीक है? अब इस चीज को अंडरस्टैंड करने के लिए, राइट, दिस, अब जब आपने ये सारी चीज समझ gaye ho, right? Let me just quickly make you go through this particular example here, right? One of the very key examples which I saw, there is a nice channel. I'm not sure whether you guys follow it or not. There's a YouTube channel called three blue, one brown. Okay, this is a nice diagram which comes up in the context there, right? So,
सर
हाँ सर,
एकदम सॉलिड, एकदम बढ़िया वाला नाम लिया आपने. The perfect person from whom we should learn everything, like all the mathematics for data science. बस वही पढ़ा था.
मैं नहीं सर, मैं सर एक्चुअली ऐसे ही ये देख रहा था, तो सर इसका काफी अच्छा द वे ही रिप्रेजेंटेड इट वाज रियली नाइस सर. मैं काफी अच्छा मुझे लगा.
He has amazing extent of knowledge, sir. He
एग्जैक्टली.
does.
दैट्स अमेजिंग सर. ये तो आई एग्री सर. तो इसमें आप देख रहे हो अटेंशन, यू नो गाइस, यू नाउ, अच्छा बाय द वे यू कैन सी हियर, राइट, व्हाट यू नाउ वांट टू क्रिएट. आपने सब कुछ निकाला, राइट? द आइडिया इज you take query dot product of k, and you can see there is a t here. What does this t stand for? Anybody? What does this t stands for?
Transpose.
Exactly.
Transpose, yeah.
Yeah. So you have query matrix. I told you if the query matrix is n cross n, right? And both the matrices are the same, right? You're taking n cross n into n cross n. You're doing a dot product between them, right? But you can't do it, right, in the context, because the values of n and m will vary, right? And that's why you make a transpose of it. That becomes m cross n. I think you can understand, right, that n cross n dot product of m, what was it? M cross n, right, results in the n cross n matrix. Did you get it? You now finally get something called as a square matrix. Why? The value of the n is, if it is 4, you also get 4, right? 4 cross 4 matrix. Do you follow up the next set of procedure which I'm talking about, guys? Is it understandable? समझ में आ रहा है सभी को, या मैं चाइनीज बोल रहा हूँ?
Yes,
Is it
yes,
understandable? Now, perfect, right, sir. Right. So now I think you can understand the significance of having this transpose, because it creates, now this, this is very famously known in the transformers world as the attention pattern. Okay. So if I talk about, you have those same words, right? This was a classic example taken by him, right? Because मैं इसको अपने तरीके से दिखाना चाहता था, but thanks to the time limit, I also did not get time to prepare much.